Hello. Hello. I'm audible?
Yeah, very good evening, sir.
Good evening, please. We can continue.
Yes, sir. So we will be wait for just a
Sure,
couple of
sure, please.
minutes,
Take your time,
and
please.
okay. Very good evening, all of you. Uh, a warm welcome to our fourth day of faculty development program on the title of Design, Development, and Optimization of Electrical Vehicles for a Green Future, which was sponsored by AICTE Training and Learning Academy, Atal Academy, and which was organized by School of Electrical Engineering, Sri Mata Vaishno Devi University. So, a warm welcome to all of you. I welcome to Arun Verma sir, our dear participants. I thanks for joining this session. So, it's my pleasure to welcome you all of you to today's expert session on advanced power electronics for electric vehicles, challenges and opportunities in Indian context. We are delighted to have with us Dr. Arun Kumar Verma sir, who is Associate Professor at IIT Jammu, who is distinguished expert in the field of powertronics and electrical vehicle technologies. So I request our student Aswini Jha, uh, please for giving the brief introduction on our today's expert. Yeah,
Thank you, sir. Am I audible?
yeah, beta, you are audible. Yeah.
Good evening, everyone. It's my privilege to introduce today's distinguished expert for the session on advanced power electronics for electric vehicle chargers towards efficient and bidirectional energy flow. We are honored to have with us Dr. Arun Kumar Verma, Associate Professor in the Department of Electrical Engineering at the Indian Institute of Technology, Jammu. He brings with him more than 15 years of academic and research experience. Dr. Verma completed his master's and PhD at IIT Delhi. He has also worked internationally as a postdoctoral fellow at Nanyang Technological University, Singapore, and as a visiting graduate researcher at the Smart Grid Energy Research Center, University of California, Los Angeles. His areas of expertise include power electronics, converters for renewable energy, and EV charging systems, bidirectional energy flow, and electric transportation technologies. He has also contributed extensively to research on power quality, active power filters, harmonic mitigation, and integration of electric vehicles with the grid. Dr. Verma has an impressive academic record with over 20 publications in leading IEEE IET transactions, around 70 IEEE conference papers, and 3 patents. He has co authored the book Advanced Concepts and Technologies for Electric Vehicles and contributed chapters such as Introduction to EV Charging Systems, where he explores unidirectional and bidirectional charging topologies, wireless charging, and grid integration challenges. His research is widely recognized. He is the recipient of the POSOCO Power System Research Award in 2016, and he has successfully led multiple sponsored research projects in the fields of electric mobility, renewable energy integration, and power electronics innovations. Some of his recent contributions focus on the design of high efficiency converter topologies, wireless EV charging systems, and bidirectional DC-DC converters that enable vehicle to grid and grid to vehicle operations, technologies that are vital for the future of smart grids and sustainable transportations. With his vast experience and deep expertise, Dr. Verma will provide us with valuable insights into the role of advanced power electronics in shaping efficient and future ready EV charging systems. Please join me in welcoming Dr. Arun Kumar Verma. Sir.
Thank you. Thank you very much. I'm audible.
Yes, sir, you are perfect audible. Yes, sir. Yes,
So basically, I kept my presentation more generalized in a way, like I have not included the research part which we are working in our lab. So this is more generalized. The idea is just to simulate the idea for research. I'll tell you where we can do, where we can go for research and all. So I kept it more generalized so that people can have some interest into it. Okay. Otherwise, if I can go for those hardware part or equations and all, then it will be sometime boring actually. Okay. So please feel free to ask your questions. Probably at the end, we'll keep 15 to 20 minutes for question answer session. So I'll be more than happy to answer your queries and doubts. So let's start. I'll share my screen.
yes, sir.
I can switch off my video by the time. Is it okay?
Yeah, no issue, sir.
Sorry. Yeah, Akash. हाँ. So can somebody confirm my screen is visible or not?
Yes, sir, it's visible. Sir, please make it in slides. Yeah, perfect, perfect,
That's fine.
perfect, sir.
That's
Fine.
fine.
Yeah, thank you so
Okay,
much.
okay. So basically, the title is the India's EV journey, or you can say the challenges and opportunities in EV in Indian perspective. So basically, we have a national electric mobility mission, and a lot of things are going on around this electric vehicle. Government has its own plan. They want that by 2030, if we can have more than 50% vehicle on the road as electric vehicle, and a lot of policies which contributing directly indirectly to the e-mobility are going on. Fame 1, Fame 2, National Electric Mobility Mission, and many more. So apart from this, basically, I mean, this is not only India but worldwide. People are concerning more about EVs, or in a broader sense, we can say alternative source of transportation. You can say like. So basically, it's an old story. Started around 1830, and then basically a battery electric vehicle that was invented by Thomas Davenport and Robert Anderson. They were using a non-rechargeable batteries in 1830, and after that, basically, you can say 1830, 1835, first small scale electric car. Then after that, first electric vehicle that was debuted in US around 1889 or 1891. Then this is how in 1899 the electric car gained some popularity. And then Edison, at that time, basically Edison takes on electric vehicle batteries, and many innovators take notes of the electric cars, and they ultimately, uh, you can say, they note the high demand of electric car and exploring way to improve the technology. And further, when people are going on continuously, and in 1971, what happened actually? They sent one electric vehicle on the over the moon. So the first manned vehicle drives on the moon, and that was NASA's lunar rover. So that was basically running on electricity and helping, and so this helps to raise the profile of the electric vehicle, because once something happened, as a worldwide and the universe, so people suddenly gain some popularity. Okay, electric vehicles raised on moon like that. Okay, and then after that in 1970 they are talking about the next generation electric vehicles. Again, 74, 77, and then around 1990, 92. So new regulation to renew the electric vehicles. So basically, when people are working in the area, so they first of all they think about the regulation, basically what regulations should be there. So new federal and the state regulations create a renewed interest in electric vehicle, and the automaker start modifying popular vehicle model into electric vehicle. Even at IIT Jammu also we have converted one Maruti Omni into electric, and even sometime institute use it, and sometime I myself using it. So that is, I mean, like in 1992, people start converting those vehicle into the electric vehicle. In 1996, EV now have a kind of cult following. So GM releases EV1 as an electric vehicle, and that were designed and developed from the ground up. So the EV1 got quickly again, I mean, a quite cult following. In 1997, first mass-produced hybrid, that was Toyota, that was introduced the first mass-produced hybrid, and that is basically the Pyrus, Toyota Pyrus. So in 2000, Toyota releases the Pyrus worldwide, and it became a instant success with the celebrities increasing its profile basically. And in 2006, first Silicon Valley startup takes on electric car, and that was nothing but Tesla Motor. A Silicon Valley startup announces it will produce a luxury electric sports car with a range of 200 plus miles. Then once Tesla takes on this, then the other automaker take a note, and then they also start accelerating work on their own electric vehicles. And in 2010, or I mean, this was first commercially available plug-in hybrid electric vehicle that was released by GM, General Motors, Chevy Volt. So it was a first commercially available plug-in hybrid, and the Volt uses battery technology that was developed by the U.S. Energy Department. In 2013, it comes with a national electric mobility plan. India comes with a national electric mobility plan. And in 2010, Nissan launches a Leaf, and then 2013, and then in 2013, basically what happened that battery cost got dropped. So once the battery cost got dropped, so because it was the most expensive part in an electric vehicle, so due to investment by the U.S. Energy Department, battery cost dropped by 50% in just 4 years. In just 4 years, so with this, basically, it helps make electric vehicle more affordable for consumers. And in 2017, the future of electric cars. I mean, electric vehicle hold a lot of potential for helping the nation create a more sustainable future. So ultimately, I mean, so many things were going on. This is historical data that when what happened for the electric vehicles, how people got to know that yeah, there's some alternate energy source. And generally, I used to say that necessity is the mother of invention. So until unless you won't have a demand, there is no supply. Okay, so the kind of demand and supply type thing. So how the how we got the demand basically. So you see this. I mean, this is a somehow overview of you can say overview of this kind of AQI index, air quality index, AQI air quality index. So uh, I am frequent traveler to Delhi. So most of the time I see in normal days also 300 AQI, 300, 350 like that, 250 normal days. In winter it crosses 500 also. So basically why I'm talking about the AQI index, because this is something health conscious. I mean, I mean this AQI index, if between the 0 to 50, this is considered as a good. 50 to 100, that is a satisfactory, and 100 to 100 moderate. Then after that, it's a poor, very poor, and ultimately severe condition. So severe means it affect the healthy people also, and especially when it's a very poor or poor, there's a breathing discomfort and respiratory illness or a prolonged exposure. So because a healthy air, okay, or you can say the healthy air quality is must. Ultimately, I remember one instance basically when I was in Singapore as my postdoc. So there suddenly once what happened that AQI index crosses around, it was around 150 or 170 like that. I mean between 140 to 170 it was okay, and it is kind of national emergency they declared, and uh, it was a national advisory that do not come out, don't go for jogging, or don't go in the park, just close your windows, be inside the house. And the university distributed N95 marks free of cost. So ultimately, what I'm saying that kind of sensitivity towards the health, okay, because at 170 and 150 also they declared the national emergency. It's not like say, any earthquake or any war or anything like that. I mean, this is just a air quality index. As an Indian, we can say, okay, but for them, it was like a kind of emergency only. And with this one, why I'm talking about this AQI? Because who are the contributor to this AQI index? Okay, so you see this one actually 14% air pollution is basically coming from the transport, and this is a then 21% from the industry on buildings and after use, all those things basically coming like that. So we have a direct emission and indirect emissions. Okay. Now when we are saying that transport contributing 14%, what exactly happening? So you see that we are the among the largest greenhouse gas emitter in the world. I'm repeating, we are the largest greenhouse gas emitter in the world. Uh, China is topping the chart, followed by US, then food waste, and then India, then after that Russia. So this greenhouse gas emission are nothing but those carbon dioxide, sulfur dioxide, SOx, NOx, and carbon monoxide. All those things are basically there. What exactly happening with this? So with the emission of greenhouse gases, the ozone layer is depleting, and ultimately the overall temperature of the earth is increasing. So when we have a increased temperature, earth temperature, then the glacier will melt and the sea level will rise, and ultimately the areas near the sea, they will submerged. Okay. Even the capital of Indonesia, that is Jakarta. Indonesia is basically all country. The whole country is basically a kind of island. They have a thousands of island, small, big, small, like that. So Jakarta, the capital of Indonesia, is also an island. So now they have a plan of around $300 billion to relocate the capital of Indonesia to somewhere else, since rising sea level is there and they are fearing that it will get submerged. Even if you are aware, or you have some any kind of general awareness, or you are interested in newspapers or news also, so you will see that one of the countries submerged, I mean small country was there, a kind of island that submerged. So ultimately this is the biggest, I mean we don't know what will happen after 50 years. We don't know that, I mean more than half Mumbai will be submerged. Okay, could be possible. Until, I mean, because rising earth temperature is dangerous. It's not only for the glacier but also the human being living in the human being living on the earth. So climate change and all those things you can see. Even even I heard that Jammu, this year Jammu has a highest rainfall, I mean if you compare with the earlier years. So anyway, so greenhouse gas basically comes to the atmosphere, and the 14% contribution is from the transportation. And apart from this pollution, basically the you can say rising crude oil price. Although in India we have almost stable prices since last 10 years, stable I will say. Okay, almost stable. Because if you see the price rise before 2014 and after 2014, you can compare this. So that's why I'm saying stable, almost stable. But anyway, a price is a different issue. The availability is another issue. Basically, we don't know how long those resources of crude oil will continue. Okay, I'll talk about that also separately. So demand and supply. So now people are thinking of alternate solutions in terms of, let's say, maybe I'm more concerned about the environment. This is the first issue. Second issue, I may be more concerned that I don't know after 20 or 30 or 40, 50 years the crude oil will left or not. I mean this is also kind of assumption. So ultimately, I'm thinking that new alternate source of energy, with the help of that we can use it for the transport. Okay, apart from electric vehicles, people are thinking about those hydrogen vehicles also, and many other type of vehicles they are thinking. It's not only the pure dependency on the electric. So before going to other details, just see this one. I mean this is a, I mean one informative slide where we say that we have a high carbon grid, medium high carbon grid, medium carbon, medium low carbon, and low carbon grid. So here, high carbon grid means whatever energy we are injecting into the grid, that is coming 93% from coal, 1% natural gas, 7% zero emission. Zero emission is basically the your solar, wind, hydro, like that. High carbon grid. Actually, why I'm saying high carbon, because 93% is coming from the coal. So how we generate energy from the coal? This is a TPS, thermal power plant. We fire the coal, gas is there, and then this steam is basically as a high pressure impinged on the blades of turbine. Turbine rotates, and in synchronization with turbine, there is a generator connected. So this turbine is acting as a prime mover to the generator, and ultimately we are generating energy. So whatever electricity is generated, already we have fired the coal, greenhouse gas emission taken place already took place. So since you are using 93% coal, so this is a high carbon grid, means a lot of carbon you have emitted into the atmosphere while generating this energy. So that's why we are calling it high carbon grid. Medium high carbon, 27% coal, 60% natural gas, and 12% zero emission. Medium carbon similarly, and low carbon. Come to this low carbon is 97% zero fuel, and then 3% natural gas and 0% coal. So ultimately, to reaching to the scenario of low carbon is very very difficult. Okay, we can have a percentage of those zero emission fuel, but anyway, just maybe you can say consider this as a hypothetical for a time being. So when we charge our grid, our vehicles from low carbon grid or high carbon grid, see this, I'm charging my vehicle, electric vehicle, I have electric vehicle, but my charging is done through the high carbon grid. So this is let me see that one. Yeah. So this is basically normal or uh, this is conventional vehicle, you can say, combustion engine based vehicle. The emission level is 13 here. Okay, emission 13. And these are the plug-in hybrid electric vehicle or electric vehicles. I'm charging those electric vehicles from the high carbon grid, and this conventional engine based vehicle is basically running on fuel, petrol or diesel, whatever. You see the emission level for this electric vehicle or this. Although people may say that they are not, they are going green, but anyway, you are charging your vehicle from the energy which is already high carbon, coming from the high carbon grid. Okay, so having an electric vehicle and charge it from the high carbon grid doesn't make any sense. It is as equivalent as to your normal electric vehicles. Okay, it is as equivalent as your normal electric vehicles. Same time, if you charge this electric vehicle from a low carbon grid, then it makes sense. You can say 13 and 4, it really makes sense. But here, if you see 12.2, 11, 10 around, and 13, it doesn't make much difference. Okay, so simple, on an electric vehicle, charge it from the low carbon grid. Then it makes sense. Otherwise, this is just a show off, nothing else. If you are concerned about the environment or greenhouse gas emissions, also, or if you think that yeah, on an electric vehicle cheaper to run or so, that is another issue. I was talking about this one basically. Let's say after I mean, see, in 1970 the production was higher and the demand was low, so crude oil was so cheap, nobody was thinking about anything because there is something more than the demand. Okay, so why to go over research? Because you are, I told you, necessity is the mother of invention. So people who are very comfortable have a huge reservoir of crude oil, and then demand was not so cheaper. But anyway, I mean, at this point of time, let's say in 2050 or so further, there's a huge gap in the demand and supply. And with this huge gap in the demand and supply, ultimately we need to think about the alternates. Okay, we have to run our vehicles, so we go either we are going for electric vehicle or hybrid electric vehicle or hydrogen vehicle or alternate fuels. Then this is the global rise in the temperature, global air temperature. You can see this annual mean of I mean, this is increasing by 0.5 degree, and so so these are the emissions basically which is taking place from the emission engines: carbon dioxide, volatile organic compound, and nitrogen oxide, all those. particulate matters, carbon monoxide, all those things are there. So these are basically formation of the these are responsible for the formation of the greenhouse gas emissions. And it was observed basically that in a Paris Agreement that keep the global temperature rise on the century below 2 degree above the pre-industrial level, and pursue efforts to limit the temperature increase even further to 1.5 degrees Celsius. I mean, this was the concern of the countries basically who participated in this Paris Agreement. This was basically on climate change only. So, and they also, the resolution was there that is just to strengthen the ability of the countries to deal with the impact of climate change. At least countries can fight with the climate change. So, they must be strengthened in order to get it done. Now, we come to the classification of vehicle. That is, one is internal combustion engine vehicle, then hybrid electric vehicle and battery electric vehicle. So we have a parallel hybrid, series hybrid, and so now this is a comparison. Already I have told that when you have a IC engine based vehicle and electric vehicle, so this is a comparison of the emission level. You can say emission is very high here and emission is low. If you see in the terms of carbon monoxide and hydrocarbons, nitrous oxides, sulfur oxides, and particulate matters, you see the combination here. Okay. So this is, I mean, it's comparison based on the harmful emission between internal combustion engine and battery electric vehicle. Then comparison of EV and ICEV. So that comparison is basically this is tank to wheel analysis. Tank means petrol tank in your vehicle, two wheels analysis. Okay. So if I have electric vehicle, I have electricity charging the battery. I'm charging a battery from the grid around 98% efficiency. Then I have a motor drive and then I have wheels. So almost 72% efficiency I have. And this is a fuel cell based electric vehicle. So around 40% efficiency I have at the wheel. When I come to the IC engine based vehicle, so petrol tank 100%, then after that engine around this much of efficiency, then driver line and wheels, so around 16% efficiency. So you can see the efficiency of the vehicles. You can say this is a comparison of battery electric vehicle or fuel cell based vehicle or normal vehicle. So here the electric vehicles have a higher efficiency. Then these are the analysis from well to wheel. Well means oil well. Crude oil are there in the Middle East. Okay, from there we are getting the crude oil. It comes to the refinery. Then it comes to the power generation and power transmission. Then battery charging and then battery electric vehicle. So around 18% efficiency we have. When crude oil come to the refinery and refinery to filling station and then filling station to engine, this is around 13%. So these are the tank to wheel analysis. Sorry, well to wheel. I'm sorry, well to wheel analysis. Earlier was the tank to wheel. Tank means petrol tank of your vehicle. Now, this is basically the comparison of EV in terms of cost. Okay, micro hybrid, mild hybrid, and full hybrid. So this is a cost around based on power level and hybridization level. You see, lot of vehicles are coming with a mild hybrid, latest fully hybrid or strong hybrid, something like that. Okay, so this is a comparison of the cost. Now, what are the challenges basically? See, till now we have seen that a lot of things we have seen in terms of electric vehicle, that why we are going for electric vehicle, what are the advantages and all. Okay, a kind of glossy pictures we have printed for a time being. But exactly, what are the challenges we are facing in terms of adopting the electric vehicle? How many electric vehicle you have seen around? I mean, around you, people may be using some e-scooters. But yeah, e-cars are there, but how many e-cars are there? So a kind of what exactly the challenges we are facing in terms of adopting those electric vehicles. So these are divided into four parts: technical challenges, infrastructure, policy, and market. So when I'm saying technical challenges, this is the biggest one. So in technical challenges, we have efficiencies of batteries, driving range of EV, charging time, safety, and environmental impact. We have batteries like lithium-ion battery, lead-acid batteries. So lithium-ion battery is having a higher power density. Higher power density means for a same power of for same power, let's say lead-acid battery and lithium-ion battery. For same power, the size of the lithium-ion battery will be smaller. Okay. In that term, basically, we can understand the high power density or high energy density. The driving range, or you can say the mileage or the driving range of this battery is more for lithium-ion battery. You have seen those e-rickshaws people are driving. They are using around 5 kilowatt and 100 ampere hour battery. 5 kilowatt and 100 ampere hour battery. So they are using lead acid battery. Lead acid battery is bulky. Approximately 1 kilowatt hour is giving you around 10 kilometer, roughly, rough estimate, okay? Or in terms of miles, this is around 6.7 miles per kilowatt hour. So if my battery is, let's say, of 5 kilowatt hour, because 5 kilowatt into 100 ampere hour, it is just a 5 kilowatt hour battery. So 5 kilowatt hour, sorry, 48 volt and 100 ampere, I'm sorry, 48 volt and 100 ampere hour battery. So 48 volt and 100 ampere means 4.8 kilowatt hour. So 4.8 into 6.7 or 7. So it will roughly give you around 35 miles, or maybe you can say 50-60 kilometer. Okay. So generally they use this vehicle around the city, and in the night they charge it. It takes a huge charging time. It takes around 10 to 12 hours in order to get it charged. I don't have I don't heard any manufacturer who can claim that I have a car which can drive for 1,000 kilometers in a single charge. Let's say I want to go from Jammu to Delhi, it's a 600 kilometer. So whether I'm comfortable that I can charge it once, I can go and come back. No, this kind of confidence is not there. Even to reach Delhi is not possible with the type of driving range coming these days. Okay. And second thing is basically, let's say I want to, let's say I have a fuel, I got fuel tank full. Okay. And I'm going on the way. Let's say I want to refuel my petrol tank of my vehicle. It hardly take 5 minutes or 10 minutes. I mean, on the larger side, let's say if crowded places there, otherwise it's hardly 5 minutes in order to get a refill. But in order to, if you let's say, first of all, the way we have a petrol pump on the both side of the road, charging stations are not available in that amount. And second thing is, let's say if it is available, I don't have time to wait for, 5 hour or so in order to get it charged. Even I don't have 1 hour to get it charged. Okay. Yes, few chargers are there. There's a basically high power, high voltage chargers. Those are DC chargers basically. They are work on for 400 to 600 volt, and they charge 80% of battery in 20-25 minutes. This is as equivalent as you are filling CNG in your vehicle. But you cannot, normal charges you can apply in your home also, but the DC fast charger you cannot apply because this is a high voltage, and working on high voltage very dangerous. So these charges could be located at a place, kind of maybe a public place, or maybe a parking lot where public utility type things is there. Okay. So the confidence, I don't have a confidence, and I have a charge my vehicle and I can move around 500 or 600 kilometers. So this is basically driving range and efficiency of battery is the biggest challenge. Then charging time is also one of the issue. And third is safety. Safety is basically Yes, long back, not long back, maybe I think within a year back, we have seen that Ola and Uber those got fire, and even many time I saw on LinkedIn that people were testing battery and it's got suddenly got blast, a kind of serial blast. So safety is also one of the concern because VMS you must have a sophisticated VMS for the safety point of view. And second is environmental aspect. Last is environment. Environmental aspect is see lead acid battery. You have a some what I would say. I mean, how to explain this? Basically, when your battery got completely discharged, you went to the market and you got some amount for this used battery resale value. You can say okay. So used battery also give you some value. Why? Because this lead acid batteries are, um I mean, you can say the word I can use for this basically degradable or maybe recyclable. Yeah, better to use recyclable word. Okay, but lithium ion is not recyclable. Yeah, although a lot of people are trying, a lot of funding they have taken in order to so that we will develop a mechanism by which we can have a recycling this lithium ion. But same time, the truth is it's not a very good sophisticated technology to have a recycling of this lithium ion batteries. So let's say in a city like Delhi, 1 crore vehicle are electric vehicle, for example, or 50 lakh vehicle are electric vehicle, and after 3 4 years they are changing the battery. So how to handle this e-waste in terms of lithium ion battery? So that need to think. So these are the technical challenges: range of batteries, driving range, then efficiency, then the charging time, safety issue, environmental impact. All those things are basically there as technical issue. So you can have a the two-wheeler roam around the city for 10 kilometer, 20 kilometer or so. Again, charge it at your home. That is comfortable. But I'm talking for a large driving range actually. Okay, within city that's fine. So you might have seen that people are having two vehicles, one for the city, another for the long drive or so. Now infrastructure wise, charging infrastructure, smart grid, battery recycling, and dedicated lane for the. So infrastructure. If I say infrastructure wise, let's say I have on one EV, how many charging? Even the Maruti Omni, which we have converted into electric vehicle, we need to go to the. I mean, because in IIT campus we have a just 400 acre right now, and from the main gate to the academic, we have around 1.25 kilometer. So we have to come down in order to get it charged. Okay, so this is just an example, but yes, uh, we don't have that charging infrastructure which is easily available. I mean, I can go. Let's say I'm going to the market, for example. I'm busy in my purchase and all. By the time I can plug in my vehicle in order to get it charged. That sort of infrastructure is not still there. So infrastructure is of also because you have some dedicated place where you can charge either at your home. Also, in a multi-story building, there's another issue to charge those batteries. Okay, then smart grid. Actually, this electric vehicle is also a kind of intermittent source. Intermittent source of. I mean, thus the way we have a solar and wind, I also consider this electric vehicle as an intermittent source of energy because uh, or not or let's say don't say source of energy, we'll say intermittent in nature. Okay, because we don't know the user behavior when he or she is going to get it charged. We don't know the user behavior. Okay, so ultimately our grid must be capable of handling all those intermittent load because in our grid, let's say let's say in the evening, in a city where we have a total 1 crore electric vehicle, or let's say 50 lakh electric vehicles. Now out of 50 lakh, let's say 10 lakh people are charging at a time. So there's a load on the grid. Okay. Ultimately, the nature of the solar and wind, and they are injecting energy into the grid. Okay. And the nature of the other source like thermal power plant, or the generation from the hydro and all. So the nature of the sources like solar, wind, and those, they have a huge inertia, those big turbines and all. So they have a different source, different nature basically. Okay, because this inverter converter doesn't have any inertia, but your hydroelectric power plant, thermal power plant, they have inertia. And same time, electric vehicle, we can consider this electric vehicle as a source also, because with the capability of V2G, vehicle to grid, that is also possible. So ultimately, what I'm saying that our grid is not capable of handling this type of loads. Ultimately, we need to make some changes in the grid, or you can say a kind of smart grid, where we are able to handle all those intermittent source load, all those things basically. And battery recycling already I have covered. Then we have a dedicated land for, I mean, we can say that we can have some dedicated land for the highways. So, in from infrastructure wise, I just heard that this Mumbai Delhi. Okay, just a minute. This Mumbai Delhi highway is having a space in between, so they are thinking in future basically. In future, they are planning to have a dedicated highway for electric vehicle, like that. So that is infrastructure. So a lot of things basically we have talked about the infrastructure. Then after that we'll come to the policy issues. Okay. So for policy issue, we have a this policy is basically most of the time it deals with the government and the bureaucrats, or you can say. So in the policy wise, we have a taxation of the vehicle, subsidies on fossil fuel, etc. Okay. So now, last year when I was filing my, just a minute. Hello. नमस्ते. uh, जी जी. मैं मैं अभी एक मेरे लेक्चर में हूँ मैं अभी एक्चुअली, है ना. वो आप वेंडर उसके लिए ना, जो अपना जो कन्वोकेशन है ना. हाँ, मैं आपसे बात करता हूँ, ठीक है. कोई दिक्कत हो तो आप मुझे मैसेज कर दीजिए, ठीक. Sorry. Actually, our convocation is going on, and I'm in charge for two committees. So sorry for this. Yeah. So basically, policy-wise, we have a taxation of vehicle and component, and then subsidies of on fossil fuels, electricity tariff policies. Basically, last time when I was filing my income tax return, ITR, so I got one link there, that whether you have purchased an electric vehicle. So government is giving subsidies on purchase of electric vehicle. So that is basically one thing. And if you can reduce the way we have reduced GST in the last month, so a lot of things got cheaper. So similarly, we can think that the component of electric vehicle, or maybe the taxation part can be taken care, so that vehicle can get the cost can get reduced. Ultimately, they have a huge cost actually. Then electricity tariff policies. So maybe we can think like people who own electric vehicle, their electricity rate may be reduced by, let's say other people are paying 10 rupees per unit, maybe 9 rupees per unit, or maybe they can give some subsidy on that electricity bill. Second thing is, maybe people who are owning electric vehicle, their toll tax may also get reduced, or maybe just free entry, just to promote that. So this is a policy matter actually. Then second is market testing and certification. Currently, ARI is only doing this testing and certification part. uh, let's say you have a, normal vehicle, normal electric vehicle, it's a cycle, electric cycle with a range of 25 kilometer per hour. For this, you need not to have any certification. This is a simple car because speed is less than 25, so no certification, nothing is required. But if you have a speed more than 25 kilometer per hour or so, then you have to follow all the rules of this traffic. So certification, testing, all thing is required. Now we need to open more and more such centers. Then let's say I purchase electric vehicle, or let's say I purchase normal vehicle, Maruti, Hyundai, whatever. I know a lot of service stations are available in the market, so if any fault or something comes out, I can easily go to the service center and repair it. The same thing is not there for the electric vehicle. I mean, for example, I used to have that electric vehicle, electric scooter, and some once it got some fault. We tried to get it fixed, but since we didn't find anybody, so my student itself opened this, and the MTech student, they fixed it basically. So ultimately, not all the users are electrical engineers. So ultimately, somebody should be there in order to tackle this thing. So the market or vehicle servicing, that is required. I mean, handy. It should be handy. Consumer perception and raw material for batteries. So raw material for batteries we'll talk about. We need a this lithium. Sorry, yeah, lithium, in order to develop that batteries for higher range. Actually, lead acid battery are there, but they are not efficient. So these are the challenges basically we are facing in terms of these electric vehicles. Now, yeah, this is basically a national electromobility mission where a government has a plan to a total investment of, I mean, 4 to 4.5 billion dollar. The ultimate aim is just to reduce the, I mean, these are the some of the fully electric car available in India. That is eddy current, Mahindra E2 Pro, e-Vitro, electric, Tata Tigor, Mahindra, and all those things are available in the net in the market. Some of the hybrid cars are Toyota Prius, Toyota Camry, VW i8, Honda Accord, all those are there. And this is basically the government plan. This is FAME 1, faster adoption and manufacture of electric vehicle, phase 1, phase 2, phase 3. And after this, basically the idea is that we can have a, like, by adopting this mission, we can have a around 60% reduction in the energy consumption and around 37% reduction the CO2 emission. If you can achieve this, definitely, as I told you in the earlier of the beginning of my presentation, that India is among the top. I mean, India is among the top chart. I mean, India is on the fourth among the top CO2 or greenhouse gas emitter. So probably we can reduce that, and we can drop down in the list. And we have a lot of government policies which are directly or indirectly, contributing to the electric national electrical mobility mission. Those are made in Make in India, Digital India, FAME, Green Mobility Fund, Smart Cities Mission. All those are there. Now, this is basically technological shift to the electric vehicles. Uh, I try to include those vehicle to grid, public charging infrastructure, digital infotainment system, power electronics, battery management, electric motor, regenerative braking, solid state batteries, composite material, and ADAS, that is advanced driver assistance system. So these are the basically technological shift, and you can see that uh, those technology innovation in electric vehicle charging, they are on-site energy source, smart energy management, battery innovations for faster charging, and this open protocol 2.0.1, and that market ready bidirectional charging. So all those basically are the technologies basically that are, you can say, technological innovation in the electric EV charging. We have a seamless payment with a more option for EV drivers. And if we say the advancement in the electric vehicle, we have autonomous driving. And autonomous means driverless car, okay, self-driving cars, or vehicle to grid. Vehicle to grid means uh, vehicle to grid. You can say, let's say in your university we have a 40,000 student or staff, including all. Out of 40, let's say 20,000 have electric vehicles. They are coming at 9, and 9 to 5 they are in the campus. So when they are in the campus from 9 to 5, their vehicle is kept idle. Okay, one electric vehicle battery is around 20 kilowatt hour, roughly. Okay, medium segment car, 20 kilowatt hour. So let's say when they enter into the campus, they have 80% of SOC, and when they want to leave the campus, okay, so with 80% of SOC, 20,000 vehicle are there in the campus. So 20,000 into 80% SOC. Okay. So let's say one vehicle is 20 kilowatt hour. So 80% is 16 kilowatt hour. 16 kilowatt hour into 20,000. So this is around, 30 to 3.2 lakh kilowatt hour energy lying ideal from 9 to 5 in a campus. So is it possible if we can transfer this energy to some area where there's a frequency drop, or in simple words we can say there's a requirement for example, let's say some hospital there and there is a critical need. Okay, can we transfer this energy? This is kind of a spinning reserve, actually, kind of spinning reserve, I'm saying. Okay, so can we send this energy to that area where it is required? So because the vehicles has to move to the, I mean, in the evening they have to go to the home also. So we cannot take all the energy. So let's say 80% is there. So maybe 20% energy of each vehicle we can divert to the area where there's a frequency drop. So this is something, a concept called vehicle to grid. Okay. Now vehicle to vehicle communication, vehicle to vehicle, the way Rafale, refuel each other in the air. Similarly, even we are thinking in that direction. We are doing some project on that direction, that vehicle to vehicle communication we can establish. We have one converted electric vehicle, another electric vehicle also we are planning to convert. Then within two vehicles, we will try that wirelessly we can transfer power. That is vehicle to vehicle communication. So this technology is also in the advancement. So these are the opportunities in the electric vehicle area. I mean, business point of view, car sale, used car, after sales service, car accessory, insurance, then charging, data, and then employment. If we come to the employment side, basically job creation. So here you can say that employment in the design and development of electric vehicle. So I mean, this is a requirement for software developer, electrical engineer, electronics engineer, chemical engineers. Okay. Then in battery manufacturing, employment requirement is there. So electrical, electronics, electromechanical assembly, I mean, all those are required. Even right now, I have seen many people are training pupils in the B class or C class cities for AI, ML, machine learning, Python, all those things basically. So they are training them. I mean, a person with just a 12th or 10th, they are training them with AI, ML. Okay, because they want to get them employed in those type of things basically. And now I just came to know that if person is doing nothing, at least he's understanding or learning the ML or this AI, ML. There's a lot of things people can do with that. So these are the opportunities in terms of employment, charging network development and maintenance. So all those things are there. Now see, electrification is imperative to address the key issues of national interest. In national interest, we have urban pollution, increasing trade deficit, energy security. So here the focus areas are basically, if you want to go for urban pollution, then COP26 commitment, where we have a, so ultimately all those are aligned with our national interest, Atmanirbhar Bharat, employment generation, energy security, all those things. So these are the policies time to time with government of India. And you see that when we are making those emission norm tight, then all the OEM are trying to fit into that. So ultimately they have to come with the EV as an option, because earlier in 2015 we have a 135, I mean, emission level. Now that is been reduced to around a 90. So when I'm reducing from 135 to 90, ultimately I have to add something here in terms of mild hybrid or strong hybrid or whatever actually. Okay, so this is something that they are forced to include this EV in their portfolio. This is a map of various states of India where we have the kind of policies, basically Delhi, Maharashtra, all those things. So demand subsidy, road tax exemption, charge subsidy. So you can find out Jammu Kashmir here somewhere. No, okay. Then this is the live basically. Anybody can go to this link. So he or she can see that how many electric vehicles are available in India, in which state, how many fuel we have saved in one day, how many fuel we have saved in a year or in liters, and then how much CO2 emission we have saved per day, like that. So this is a live and the www.fame.india.gov.in, www.fame.india and .gov.in. Now these are the batteries. I told you we have a lead acid battery, nickel cadmium metal halide, nickel metal halide, lithium ion. So you can see lithium ion is having a highest mileage or driving efficiency. Other batteries like future lithium ion, zinc air, lithium sulfur, lithium air, they all are under R&D or under development. Now see the lithium. The lithium basically, these are the countries having lithium: Australia, Chile, China, Argentina, Zimbabwe, Portugal, Brazil. India, recently we have a lithium reservoir in Riasi and Nagaur district of Rajasthan and Riasi of Jammu Kashmir. But in order to export them, it will take time to get them into the phase. But yes, because earlier we don't have a lithium, so government of India framed that KABIL, Kabil, Khanij Bidesh India Limited. Basically, it was with the help of Tatas, so a kind of public sector unit. So the purpose of this Khanij Bidesh India Limited was to negotiate with the like-minded countries who are not our enemies, at least, to help them in exploring the lithium, or maybe a kind of trade-off that you give us lithium, we will give you this, something like that. And apart from that, search the lithium possibility in our country also. So now you might have noticed that lot of reservoirs we have found in Riasi district. We have found lithium in Nagaur. We have found lithium, and also in Andaman Nicobar we have found the petroleum reservoir also. Okay. Actually, one thing is China is a source of this permanent magnet and all. We cannot rely on China for any kind of emergency. Like you can see, we need batteries for satellite communication, mobile network, and everywhere where we need power or storage, we need a battery. So in any kind of emergency, we cannot rely on China. So ultimately, the KVIL is formed in order to tackle this issue, and ultimately, it's doing nice. These are the technologies related to electric vehicles. You can see we have a complete vehicle diagram where we have a grid. We are taking energy from the grid, charging it from the grid. We are converting this AC into DC. Then we are charging this battery. From battery, again, we are using one inverter that is called traction drive, and then electric motor. And ultimately, we are running the vehicle. So here we have people who are from power electronics background. They can think of developing a new AC-DC converter for charging, for PFC converters, DC-DC converters in order to charge this battery. People with a power system background, they can think of some AI, ML, or charging algorithm, smart charging algorithm to charge this battery, maybe in different environment condition. Let's say in Leh Ladakh, we have a temperature in minus, in Rajasthan, we have a temperature plus 50, like that. Okay, so different environment, how our battery will work, and different situations we can think about this battery life degradation and fire hazard. So many things basically we can think of in terms of battery management. When we are thinking in terms of battery management, obviously the role of AI, ML, and all those things will come into the picture. Once battery got charged, we have a traction inverter, so convert the DC into AC and then feeding to the electric motor. Let's say depending upon the type of motor we have here, the we are now motor control is also one of the research topic. Design of traction inverter is also one of the research topic. And after that, this whole system is at a higher voltage, and this is auxiliary supply. Auxiliary supply is basically your electronic load, wiper, headlights, stereo, all those things. That is at a completely lower voltage. So one line is at a higher voltage, another line at a lower voltage. So to design those DC-DC converter at low voltage is also one of the topic for this. So this is overall diagram of electric vehicle. This is a type of basically electric vehicle service equipment and their component. Level 1 charger, level 2 charger, level 3 chargers. Level 1 is basically for a 1 kilowatt range. I'll give the data for this. And but before that, we have a two type, onboard charger and offboard charger. For onboard charger, this is only for low kilowatt. Okay, less concern about battery heating. This is 1 kilowatt, 2 kilowatt, 3 kilowatt, like that. So this is inside the vehicle itself, and doesn't have a much sophisticated VMS. But for a off-board charger, they are pole mounted type outside the vehicle, and they have a high power rating. So whenever we are go for a high power rating, we go for a off-board. Otherwise, we are going for on-board chargers only. And basically it removes weight from the vehicle, has a sophisticated VMS. So you can see up to 6.6 kilowatt we are going with a onboard charger, and beyond that we are going for off-board chargers. Role of electric vehicles in the smart cities, smart grid. You can use vehicle for you can see like V2G. Already I have told you what is V2G. V2L, we can supply any load from the vehicle. If you see, when I was a kid in my village, people used those tractor batteries in order to run the televisions, just to see that Ramayana and Mahabharata. So, I mean, at that time, people are aware about, before 25, 30 years back, they are aware about, all those things, that how we actually can use as a load. Similarly, we can do here also, the same thing we are doing. So vehicle to load, we can, because the vehicle is now your source of energy. Okay, this is a kind of prosumer. One word, prosumer, means consumer as well as a producer. So why consumer? Because we can charge it from the grid. And why producer? Because this battery can be utilized for another purpose. Here we are saying V2G, here we are saying V2 home, V2V also, vehicle to vehicle transfer. Okay, so we are also coining one another term, that is prosumers. So battery owner is a kind of consumer as well as producer also. This is how the main benefit. Let's say because this battery is a standalone system. Your vehicle is a standalone system. It doesn't affect from the rain or cyclone or whatever. So in case of emergency also, you can use this power as a one of the power which is not connected to the grid. So if your grid is also damaged, in that case also you can utilize this power. Is a V2G. Okay. So V2G and G2V, this is grid to vehicle, or vehicle to grid. Again, first of all, we are using this to charge the battery here of the grid, and then ultimately we are sending back to the grid also. So I'm stopping here. I'm open to your questions, because we said that we'll keep around 10-20 minutes for this question answer session. So if you have any doubt or any question, please feel free to ask. Thank you. Yes, do we have any question, please? Dr. Jatin, please, if they have any question, they can ask. Okay, okay, just a minute. So, do we have any question, please? Organizers, Ashwini, are you there?
Yes, sir. We are finding out the question, sir.
So
Give,
I'm done. Now, if anybody has any question, please they can ask me.
give us a moment, sir.
You have a lot of participant. Total 160 participants are there. It's a huge success for your program. Great.
Participants, do ask your questions in the WhatsApp group. I'll convey your message to sir.
I think they can type their question also here. Also, they can type their question or so. Okay. A new question has put in question answer session. Okay, one question is basically Burla Sridhar. Can we use lithium-ion battery only at night and power the motor directly from solar energy during the day? And usage time may increase and we may reduce the waste of lithium. Actually, see, solar is an intermittent source of energy. Okay, so if you are directly feeding them, that there is a change in the because intensity of the solar is getting changed. Okay, so storage is must because this is an intermittent source of energy. So we cannot directly provide it. We need to get it fixed first, and then we can utilize for motor and all. So it is not like that we can directly use it during day and then later on we can use battery. Not like that. Okay.
Sir, we do have a question on the WhatsApp group from Harish Kumar. Sir, how to solve synchronization problems arise due vehicle to grid and vehicle to load, grid to vehicle?
Synchronized problem will arise basically because when I'm saying that vehicle to grid, it's not a problem of electrical engineer only. It requires expertise from people from computer science, electrical, electronics, mechanical. Okay, so synchronization means we have a cloud server, okay, and there's an operator who will schedule this power. Like that, we have a kind of mobile app, okay. From this mobile app, we can fix our timing of charge and discharge because in another other countries they have a flexible tariff plan. Okay, flexible tariff plan is the rate of the electricity changes due to according to the demand. Okay, so we can fix through mobile that my vehicle can charge at this time or discharge at this time depending on the rates of the electricity. Okay, so synchronization will definitely there is a issue with synchronization, but yes, we need a perfect control use of AI, ML, and all those things. So in order to get things done. So in this way, control algorithm must be proper and robust. In this way, we can do.
So we have a new question from Chandrasekhar, sir. Can we use this technology for the small child like toy car?
Which technology is talking about? V2G?
Most probably yes, sir. B2G.
See, V2G, we need a high power actually. Toy car is having a small power because toy car, how much toy car you can run? See, maybe few meters. It's so how much power you can transfer. I mean, there's some power loss also. If you are transferring a small power, then ultimately it will get lost. So better we can use this technology for a high power ratings, not for small power rating. I have a one question from Manan Desai. Any solution for the waste battery after 4 5 year? E-waste solution with respect to e-battery. Yeah, lithium ion battery. I told you in my talk also that lead acid battery has a recycle value, but lithium ion still people are trying. A lot of startups and so many things are there. They are trying to find out some solution for the recycling of the lithium ion battery. But anyway, at the end of the day, we will get some solution. So battery waste is one of the problem, especially lithium ion battery, not the other lead acid battery. So currently people are trying with that, but we don't have any concrete solution with 100% success also. Yes, please. I have another question, Satyajit Sahu. I want to know how intermittent charging the EV affect the battery life. Is there any method to optimize it and it more durable? How intermittent charging means what you charge, yeah, they see there is a fixed cycle, fixed number of cycles in the battery, charging discharging cycles. Okay, so intermittent charging, you charge for some time then reduce, I mean you are talking about in this way, because ultimately battery has a definite life, okay, fixed life you can say. That life is in terms of charging discharging cycles only. The way you have LED bulb, number of time you turn it off on off, it will, the life of this uh, bulb will get reduced. Okay, so that depend upon the number of charging discharge cycle, definitely it will affect the battery life. And if you say method to optimize it, basically yes, a lot of optimization things are going on. You have to design a program for that and run an optimization program, definitely you will find out something, because ultimately in optimization we are doing with maximum or minimum. So if you want to maximize the life, then you need to tackle with a certain parameter, battery parameters actually. Okay, so this is a kind of problem for research itself, that how, well, people are doing so many things in optimization. So optimization technique we can use for this. I hope I have answered. If any
Sir,
further query is there, you can just ask me the question. Yes, please.
there is a question on the WhatsApp group. What are the impact of EV on power quality?
EV on power cut. I told you that our grids must be capable of handling the EV load. Okay. When I'm saying vehicle to grid. So when I'm injecting into a grid, my injected voltage and current must be in the same phase, must have a THD less than 5%. Okay. So all those things basically I need to control. If I control all those parameters, everything is fine. There is no issue of power quality. But when I'm injecting, I must keep it in a perfect by having a control and all. Any other question, please?
We have one more question from
Yeah.
Harish Kumar. Sir,
Yeah.
can you suggest any idea how to start research on sodium ion battery design and modeling for EVs?
Actually, I'm not working in the EV, but anyway, basically, we need to definitely uh, developing a new battery which is having a higher driving range, high efficiency is basically the responsibility of the people from the material science engineering or chemistry, okay, or physics, those or chemical engineers. The onus is basically on them to develop a new battery. But yes, need to do extensive research on the material side, the material which can have a large driving range or large storage capacity, why with the help of that we can develop a battery which can have a higher driving range or higher mileage. So this is basically depends on the quality of material which we are using and their energy capability, energy holding capability basically. So this is more onto the people of material engineering. And so right now I'm working on the charging side of the battery, not on the material side of the battery, but whatever idea I have just shared with you, please.
So we have one more question. Apart
Yes.
from the steam power station greenhouse gases, is it battery producing any greenhouse gases while in manufacturing and while using in the EV?
Actually, yes. One thing, very good question. Actually, when uh, battery manufacturing itself required energy. Okay. So if you see in one of my slide, we talked about the particulate matters and all. So when during the manufacturing process, those particulate matters and all is more than the other conventional vehicle. Okay. So, if you say any carbon emission during the manufacturing process, that is, I cannot comment properly on that. But yes, it's some, yeah, some energy is definitely there. Some energy is required. While because you have a lithium ion and so many things are there, definitely it is there. But how much percentage or so, it is not possible to comment. But yes, it is very less than the other earlier counterpart. Okay, but yes, it is there. It is not zero for sure. Yes, any other question?
So we have one more question on the Q&A section. As a normal user, it is not possible to always charge it from 20% to full charge, and sometimes we have to charge it from 50 to 60% to full because of future demand.
Yes.
So any suggestion to maintain battery life taking account of this type of charging discharging cycle?
See, here basically we need to keep our battery full as per our requirement. This is for sure. Okay. For the mobile also, let's say you have a mobile of 20%. Now you are going somewhere. So you definitely you want to charge it. Okay. Or you have a 50%. Now you are leaving home. So you may be thinking that my mobile should be 100% charged like that. Okay. So this is basically depend upon the demand. Yes, we have a definite number of cycles. So sometimes people say that when it is uh, almost discharged, then only you start charging. I mean, your mobile should not be almost discharged or almost full. It should be something in between. Let's say you can start charging around to 15% or 10%, then go up to 90% or so. Okay, but that is totally depend upon requirement. Or if you really want to optimize it, then use the way I told that at 10%, from 10% to 90% all the time. But that is not ideal case actually. A lot of time you need to recharge maybe from 50 to 80 also. Something like this happen. Okay. So ideal is charge it when it is actually required, discharge it. I mean, sorry, not discharge, but yeah, charge level keep between 10 to 90, something like that. Okay, I hope I have answered. If you have further question in that, please ask me, because whatever I can understand from your question, that only I have told you.
So one question is more from Manan Desai in the Q&A box. With respect to Sahu sir's question, regenerative braking also counts in intermittent charging. More battery charging cycle leads to damaged battery early.
See, recharging is basically helping you. I mean, see, this basically this regenerative is basically helping you. Okay, so see, you can understand in that way that in emergency you are getting some power out of it. So there's a kind of trade-off situation. Okay, there's a kind of trade-off situation, because let's say I have a V2G capability and I have a mobile app where I am just saying that when the electricity price is less, my battery can go into the charge, and when electricity price is high, my battery can go into discharge mode. I'm purchasing when the price is low, when I'm discharging when my price is high. So ultimately, I'm doing this charge discharge frequently. Okay. So we did one analysis, and there's a paper from our side that is available on IEEE, that when we do this frequent charging, discharging, frequent charging, so it doesn't affect the battery life. This is also there, but this was only simulation study with the data available from the NERL website actually. Okay. So with one of our finding, it was there. We couldn't continue that finding because I was in USA at that time when I was doing I mean, this part of work. But after coming back, we could not continue. So in one of our simulation analysis, we found that this frequent charging, discharging doesn't affect the battery life also. Frequent charging, discharging. Let's say for short time you charge, discharge, like that. Although we have a fixed number of cycles, yeah, my word may be contradictory now. Okay, but yes, it was there. We have find out this, and this paper is available online also. Somebody can refer it.
I guess all our participants have got their answers. No more questions are there.
Okay, so if no more questions are there, I think we can wind up the session. Is it fine?
Yes, sir. Thank you, sir. Thank
Okay,
you so much.
thank you very much for your questions. Thank you very much for your patience listening. Thank you very much.
Okay, participants. So the first session is over for today, and now we are going to take a break of few minutes. We'll be right back very soon.
Good evening, ma'am. Am I audible?
Hi Anushka. Yeah. Yeah, you're audible. Can you hear
Uh,
me?
yes, ma'am, we can hear you. We will
Yeah.
start sessions shortly. We
Yeah.
just took a
No
break of
problem.
5 minutes.
Yeah.
Yeah, okay.
Yeah.
Thank you.
Give us a moment, ma'am. We are waiting for the participants to join.
Very good evening, all of you. So, thank you for dear participant. Thank you so much for your kind patient. Now we will move forward to our next session, technical session, which was delivered by Dr. Minal Chandra ma'am, who is principal scientist at CSIR, Central Road Research Institute, New Delhi. So I request our student Aswini Jha or Anushka, please please give the brief introduction on our expert.
So, good evening, everybody. It's my pleasure to introduce Dr. Minal Chandra, Principal Scientist at the CSIR Central Road Research Institute, New Delhi. She holds a PhD in engineering with specialization in sustainable transport systems, and she has also served as a postdoctoral researcher at the University of California, Davis. Her research focuses on electric mobility, sustainable transport planning, and travel demand modeling. Dr. Chandra has authored several impactful publications in top international journals and has presented her work at leading platforms such as Transportation Research Board Annual Meeting in Washington, D.C., and the World Conference on Transport Research. She has also led and contributed to major national and international projects on EV adoption, charging infrastructure, mobility planning, and urban transport policies with funding support from both Indian agencies and the US Department of Transportation. Her contributions have been recognized with honors such as the AWSR Award by the Government of India, and she serves as a member of the Bureau of Indian Standard Committee on Transport and Logistic Services. In summary, Dr. Chandra is a dedicated researcher driving innovation in sustainable mobility and electric vehicle transitions. Please join me in welcoming her.
Thank you, Anushka, that for a wonderful introduction. Now, should I just share my slides now?
Yes,
Yes,
ma'am.
ma'am,
You can
sure.
send.
Yeah, just give me 1 second. Okay, so can you guys see my screen? Um,
Yes, ma'am. It's visible, ma'am.
it's
Yeah.
visible. Is it in the presenter view, or you can see the just the slide?
It's just present view. So,
Okay.
is it possible to make
Yeah,
it
yeah,
full
yeah.
slide?
Yeah, I'll just do that. Okay.
Yeah, ma'am.
Now
It's perfect fine, ma'am. Yeah.
better, right? Yeah. Okay.
Yes, perfect. Thank you, ma'am.
Yeah.
It's over. Hand over to you, ma'am.
Yeah.
Thank you.
Thank you. Thank you, Jatinji. And thank you, everyone, for inviting me to this wonderful workshop. The whole topic of EVs is very close to my heart, and I'm really excited to be part of this. As you all know, my session will be focused on electric vehicle demand and supply strategy. Uh, and Anushka has already given a very beautiful brief introduction about me. So I'll just start with the topic. Okay. The slides are not moving. What is happening? Can you see a change of slide? Anyone? Am I not connected? Okay, yeah, perfect, great. So I prepared a about me slide, but it has already been presented. I'm currently working as a principal scientist in CSIR CRRI. Central Road Research Institute is one of the national labs of CSIR, where we work exclusively on road infrastructure, starting from transport planning, environment, road safety, up, I mean, the different kind of pavements, the flexible pavement, the concrete pavement, the geotechnical side, bridges, as well as pavement evaluation division. So we work on everything on the road, below the road, on the road, above the road, and even the planning aspects. So I've been a part of CRRI since June 2016, well over 9 years now. And in between, for a period of 2 years, I took a leave and went to pursue my postdoc at ITS, University of California, Davis, and where I worked in their really amazing center of electric vehicle research center. And my today's presentation draws heavily on the work I did there. And the things I work on are exclusively like EV adoption, demand supply strategy, forecasting. In the past, I worked a lot on EV charging infrastructure. We developed an in house software for optimum charging location for EVs in any urban area, any city. Then transport decarbonization and also road safety. So I'll just take you to a brief outline of today's presentation. We'll start off with background. It's just a very small background. We all know about EVs and what's happening. Then we'll do a deep dive in section 2 and in section 3. The section 2 is on focused on global EV demand dynamics. Section 3 is on the supply side and trade dynamics. And the fourth section basically focuses on what kind of implications we draw from, the demand and supply side and trade dynamics, and how that we can use for policy, industry, and, research aspects. So, starting off with the background, last year in 2024, the global EV sales crossed more than like 17 million units, which was a straight away 25% year on year rise compared to 2023. And as we've been seeing from the last at least 6 years, China has been leading in this sale. Like even last year, 60% of the sale in the EV market was done in China. So that's a really huge amount, right? And this demand and the EV, like the EVs are no more in a experimental phase, I'd say. EVs are mainstream now, like the way they have picked up in the last 3 years. And this growth and this acceleration will really keep going. I believe that because there are several factors I feel are responsible for that. First of all, there's the insecurity about the fuel scarcity and fuel security aspect because of the various geopolitical tensions and fractures which are happening in the world right now. So any country which heavily relies on fuel import would like to take the way of energy security through electrification of their transport fleet. I think that's a very crucial and a very smart way of, in a way, securing your energy for your country. Then, secondly, because of the reasons of climate change and pollution, the norms, the emission norms in many countries. I mean, very recently, few countries, not to name anyone, have been, rolling back on that. But still, like European Union region, as you know, from 2035, it has already been passed in their parliament. From 2035, they have a complete ban on ICEV vehicles, that exclusively run on petrol or diesel. So, and also the consumer incentives, many governments, like even our government, through fame schemes, they have, like right now they're targeting two wheelers and the public transit, especially the bus fleet, but they are providing a lot of incentives for people to take up EVs. And all over, there is a lot of investment around setting up of EV charging station, charging infrastructure. So I think EVs are they're already mainstream and they're gonna take over. Like there should be no doubts about that. Also, coming to the global south, the emerging markets of India, Asia, and Latin America, uh, they are entering, like, we are in a very early adopter phase, but we are entering the adoption acceleration phase. Like, if you look at any growth curve, right? And why is this happen? Why will this happen very soon? Because of the cost parity and a lot of localization and in manufacturing, in policy support, in many things happening. I'm sure all of you in your state or in your cities, you must have noticed, like compared to 3 years back, probably you're seeing more electric chargers, you're seeing more electric cars, you're seeing more electric two-wheelers around you in your neighborhood. And that kind of gives a kind of an encouragement that everyone around you is, there's a support system. So that actually also boosts the sentiment of adopting a new technology. Um, but even then, EV adoption is remains highly uneven. The top 10 EV savvy countries are the one who own the 90% of the global stock. So, and even like, for example, if you take India, okay, amongst all the states, they're just the top three, five. Like most of the EVs are found, I think Delhi is, NCR of Delhi is kind of leading in that. Then Maharashtra, Karnataka, and like a handful of states are there who are kind of leading the electrification of the transport in the country itself. So there is a lot of disparity in that sense. Um, Now I'll just give a little bit of background on EV supply challenges. Uh, EVs depends on batteries, and battery production is highly, like geographically, very concentrated in these three countries: China, South Korea, and Japan. In a way, like more than 75% of the cells, cells are bound together to make the battery packs, and more than 90% of the cathode and anode, materials originate from these three countries, which is not very good for a global EV, supply chain scenario. Again, there are some upstream bottleneck, like getting the raw material. Upstream bottleneck means that, in the raw materials of lithium, nickel, cobalt, which goes into manufacturing the batteries, it's very essential. And since there are different bottlenecks, it also, leads to cost instability and affects the production capacity of OEMs. And as we've seen, the OEM production plans are kind of misaligned with the regional demand. But this is more severe for legacy OEMs, which have been there for decades and are heavily invested in, ISEF technology, producing vehicles which run on petrol, diesel, and they kind of have an inertia to shift. I feel they still feel that electrification is probably just a phase and it will go away. But that is kind of, but this mentality of the legacy OM is kind of really good for the new players who are like 100% EV, manufacturers. Like, I'm not just talking about Tesla. Look at many Chinese manufacturers like BYD, Geely, and like KZ Electronics. The numerous, there's so many of them, and they have entered in the last 2 to 3 years. They have entered European market like anything. Like they're kind of capturing the market. Um, Okay, so as we were talking, like most of the EV targets, we set the target, but there cannot be any EVs without the batteries and the cell and its components. So when we set targets, we also need to work around the whole supply chain thing. And also at the same pace make a grid ready, make a charging infrastructure ready for the huge amount of charging requirement that will come up in the future. If you're setting a target for say around 30% of your fleet has to be electrified, so your grid has to take that much of load, and how that load would be shared, looking at the duck curves and how that should be dealt in. I mean, a toolkit or a plan should be ready with all the countries, I'd say. So with this, I'll take you to the global EV demand dynamics. In this section, I'll discuss kind of two of results from two of the studies of mine. The first, which looks into the factors that affect the EV demand or the growth of EVs in any country. The second is on forecasting the global light duty EV demand 2035, 2050. Because measuring your demand is very important. Uh, you need to know, you need to measure, you need to understand, you need to forecast for where you're going to plan ahead for all the things we just talked in the previous slide about the EV supply side challenges, right? So I hit the ground running with the first study, which was published in 2022 in the Journal of Transport Geography. Um, well, this study was actually a cross country panel data study of countries which looked at the different policies that help push EV adoption, the social demography of the countries, and the national commitments of these countries on like the impact of all these on the EV demand on these countries. So the countries which I took were the top 9 countries, which had around more than 95% of the EV stock in 2021. But I also included India because India was grossly missing from any such cross-country panel study. Um, the study uses all the open source data. I mean, as you'll see in my other slides also, I'm a huge fan of open source data for any research. I really recommend and enjoy working on open source data. Open source, by that I mean data which is publicly available, which um, can be used by any other researcher and reproduced. I mean, they can reproduce the same results um, on what I'm working. So that's one reason I really like it. So yeah, let me talk about the variables, the parameter, the data I used for this. The first being the EV stock, the number of EVs in the country. And for that, EVs in this study includes both the battery electrics and the plug-in hybrid electrics. I'm sure you know battery EVs are the ones which only runs on pure battery. You can only charge them. That's the only way to kind of refuel them. And plug-in hybrid electric vehicles, they have both the transmission engine and also the electric battery. So to refuel them, you can either charge it or you can put in petrol or diesel or whatever the fuel on which it runs. So it's plug-in hybrid electric. So yeah, these data I got from IEA, International Energy Agency's Global EV Outlook of 2020. Global EV Outlook is an excellent annual magazine that IEA publishes every year. It comes out in summer, around June, July-ish. So if you are an EV researcher, you're looking to gain knowledge, I would highly recommend keeping a track on this annual publication. It's really good. I also got the EV chargers stock, like how many chargers are there in these country, number of EV chargers from this source. Also the fuel price, you know, of uh, gasoline, the petrol in the countries. The next parameter I used was the share of renewables in the total electric production. This I got from the Global Energy Statistical Yearbook. Population density, that is the number of people per square kilometer from World Bank, GDP per capita from World Bank, and age, mean age of the country from World Bank again. And I use policy and incentives, like what country, like gives what kind of incentives for purchasing of EV of any category, or what do they have EV favoring policy? You have to do quite a I had to do quite a reading, looking at these country. Visit a lot of websites on these country to understand what kind of incentive they're giving, how it works. So yeah, so I frame a panel data analysis. A panel data is, like it, you know, it's across time, right? For this panel, the data I took from year 2012 to 2021, yeah, 21 or 20, yeah, I guess so. So a two-way fixed effect model is the one in which you can fix both the country and the time. Like for any panel data, you basically run a Hosman test, and you kind of figure out, is it most suitable to run a one-way fixed effect model or a two-way fixed effect model. So based on some statistic, um, uh, the two-way fixed effect model is the best model for this. And so log of EV stock is the dependent parameter, and rest of the parameters are, the independent parameters. So let me take you to the results, not bore you with a lot of statistics, because um, that's not the focus of the session. So yeah, what I found was, what affects the growth of stock in any country, growth of EV stock in any country. The most important factor came out as the share of renewables in their total energy production, and which makes total sense. The more a country is less dependent on fossil fuels for their electric grid, the more keen the country would be to, um, electrify their fleet. It's the TCO and the whole, the total cost would be like, um, you know the whole LCA would be much lower for these countries, and made much more sense. Again, since EVs have a higher upfront cost, even now, it will take some time to reach the cost parity with the ISIFs. So the richer country, the countries with higher GDP per capita, showed a larger amount of, a good growth in the EV stock in the country. Again, having countries with a better charger stock, like a better charging infrastructure, showed more, growth in EV stock. Um, the factor of age is less. That means more younger people are affecting, you know, I mean, it wasn't that strong, but okay. But yeah, the population density had a kind of a negative impact on the stock, which kind of makes sense, and also has I've seen similar kind of results in other studies. This is probably because charging, EV charging requires the infrastructure to be placed at different places across, specified optimized location, the distance. And when you think about it, having and bringing in a whole EV ecosystem will also require not just an EV owner or a transport specialist. It'll also require a real estate guy on the table, because to install a EV, the charging infrastructure, you need land. Who has the land? These guys have the land. So you need more, in terms of space, and um, a higher population density is more um, prone to using more public transit, more mass transit, rather than EVs. Again, when we come to the policies which a country has, like the three kind of policies I considered was, if a country has put a target on having so many chargers. Like by 2030, we'll have like 20,000 chargers set up in the nation. A country which gives subsidies, like it includes both the monetary subsidy as well as to the manufacturers as well as to the buyers, both sides. And also has a EV target, like for example, 30 at 30. By 2030, we'll electrify 30% of our fleet. Okay, so if the country has is into any of this, it has more stock, especially the countries which have set a proper EV target, showed a better growth in their EV infrastructure. Um, I mean, since the EV stock contained both battery electrics and PHEV, um, further it was evaluated to see if there is a difference between these two. So separate models were run. Uh, the effect were pretty much the same, except for gasoline price. If you have a look over here, uh, the higher the gasoline price, a more positive effect on the growth of EVs, the blue bar. But that increase in gasoline price has like a negative impact on the growth of the PHEV stock. But yeah, it's not significant. So, okay. Further, as I said, the study also looked into the effect of national commitments of EV demand. Um, EV 30 at 30 was a campaign which was signed by a lot of countries. So the study looked at whether the countries in our panel is a signatory to this EV 30 at 30 campaign, and to see how that, um, and the hypothesis here was a country whose signatory or who's more committed to such EV campaign will provide better policies and better incentives in terms of better in charging infrastructure. Will have the cost of gasoline and renewable energy production will be little different in the country, and different in the sense like the cost of gasoline would be expected to be a little higher, and the renewable energy production is expected to be a little higher, and the country would provide have a better higher charger target, will provide more subsidy, and you know so here again, what we found was the gasoline price had negative effect, but it was like not very significant. But yeah, renewables, they showed renewables and the country, uh, they have there's a very strong correlation between the country being signatory to national or having a national commitment to EVs, to the growth in the renewables, which ultimately affected the growth in EVs. So from our study, we found that renewables kind of really drive the countries to a higher growth in EVs in the country. Bringing you to the next study, this was done during my postdoc at UC Davis at ITS. So in this study, I projected the global light-duty vehicle and EV sales under changing economic scenario, under a high and low economic scenario. Uh, so starting with why did I look into the global economy and why am I looking at the whole light-duty vehicle fleet thing? Because the idea of this study originated from like EV should not be just seen as a standalone vehicle segment. EVs are actually part of the entire vehicle fleet. So since our study focused on light duty vehicles, okay, so instead of just directly forecasting the EV using some machine learning or various data you know mining methods, what we did was we started off with the ownership, the vehicle ownership, okay, and how it grows in the country. Like the figure over here shows you, it's actually along a growth. The black curve is actually an ideal growth curve, and the y-axis is the LDV ownership per thousand population, and the x-axis is GDP per working age capita. Working age is 15 to 64 ages, as described by the World Bank. So you can see how the vehicle ownership has evolved, like with increasing GDP per working age capita. You can see how the countries look at China, like it really kind of almost went vertical, like really big growth. India is very low there. Like currently, we are like having 35 light duty vehicle per thousand population, which is like very less. Um, you can look at the top right corner countries of Western Europe, US, New Zealand. They are at one of the highest levels of light duty vehicle. They're almost saturated because you can see the curve has almost flattened, right? Um, Having 800 vehicles per thousand population, that's a lot, right? And we are at 35 at thousand population. Look at Singapore. Like there hasn't been the GDP has increased, but there hasn't been any growth in their living ownership. But that's due to other reason. They do not encourage vehicle ownership. It's a whole different policy thing in Singapore. So yeah, what we did here was we started with the LDV ownership and went to projecting the from the current LDV ownership to the future LDV ownership for all the countries. Okay, and looking at like from that LDV ownership, we got through our vehicle retirement model, looking at countries' commitment, how much of fleet they're planning to convert. We predicted the EV stock, then EV sales, and then we went on to seeing how much of that EV will be battery electric, how much of that will be PHEV, and also like what will replace what. Like in future, will the new ICEVs will replace old ICEVs, or the new EVs would be replacing old ICEVs, or they'll just be replacing old EVs and those kind of things. We If you're projecting anything, we need, and since GDP, like economy was one of the most important factors, it is a very important factor in vehicle ownership. We took a high scenario and a low economic scenario, to just kind of get a range of an idea of things. So I'll just walk you through what the model does. This study again uses all the open source data. The demographic data was from UN and World Bank: GDP, population, working age, urbanization percentage, the population density. EV policy data came from reading the policies of various countries and various reports and other studies. So we looked at the EV country targets, commitments, legislation, everything. We also included LDV ownership, obviously, that was a starting point. And we also included the two wheeler ownership because unlike the West, in the Southeast, as the GDP of a household increases, we don't straight away go to owning car. We kind of start with owning a two wheeler first, or maybe two of the two wheelers, and then probably then go over to have a car. Like, so it was very important to include the two wheeler ownership because it was a global model. If it was just a model for developed countries, we could have done away with it. But what if we did not include this? If we did not include this, I think it would have led to a very high, like a overestimation of LDV ownership, especially in the you know developing nations. Then the model also included the road network data from IRF. So the model had 190 countries aggregated into 65 countries and region. Now, looking at the framework, uh, we start with the current vehicle ownership, and we use a growth curve method. It was a compass curve, but it was modified because we included all the demographic parameters, all the motorization two-wheeler parameters. That led to the projection of future LDV ownership. From there, we projected the total stock, how much stock of LDV would be there in future. From there, we created a vehicle retirement model to reach to the sales, LDV sales, and using the country EV targets and power stock projection, we went to the, you know, like the EV sales, light duty EV sales. I mean, I know it's a lot to take into, but this paper has it got just published 2 months back. I'll when I share my slides, I'll make sure I put in all the references to all the material I have referred to in the presentation. So, as I was saying, LDV ownership is a function of income and working age population, because working age population is the population which historically is drives the consumerism in any country, especially when you talk of vehicles, cars. So that is why we focused our research more on GDP and the working age population rather than the entire population, because old people and children, they do not earn, they do not go to buy car, they will not own the vehicle, right? So, and also like in my previous slides, I talked about how US, New Zealand, Western Europe has kind of saturated. So we needed to figure out when, since we're using a growth curve, we needed to figure out when each of the country would saturate in their LDV ownership. And this model of ours, it did not use just a common growth for all the countries. It created individual growth curves for each of the countries, which was a function of population density, urbanization, and the two-wheeler ownership. We really think taking into account the developing and the developed, these three factors kind of lead to what would be the saturation level of the vehicles. So here I'm presenting the growth curves, the LDV ownership curves. On the left is under high economic scenario, and the left is the low economic scenario till 2050 for the countries China, India, Japan, Singapore, USA, and the world, like the brown curve on an average for world. So you can see starting with let's start with USA. It's on the top, the light violet curve. We don't see much of a difference. It's anyways between 700 to 800 vehicles per thousand population. That's already a lot. Japan also in Asia, it has one of the highest vehicle saturation level, and it kind of just maxes out close to 600 in both the scenarios. Looking at China, that the, under high economy scenario, just from around 188 vehicles per thousand right now, it might go close to like almost 500 vehicles per thousand population. That's really steep. Even in low economic scenario, it goes well above 300. Singapore, not much, because there is the policy, they do not want their resident to own vehicles because of the parking shortage, and it's a very congested country in itself. So no more cars. Um, Look at India. Right now, we are at around 35 vehicles per thousand population. On a very good high economic scenario, we might go close to 300. Um, in not so good economic scenario, we'll stay below 200. So this might seem little small, but I just want you to do the math. Um, it's per thousand population. So, our population almost 1.4 billion right now. So just do the math and see the more amount of cars we might have on our roads, which are already choked up. So yeah, and the world is, it might go up to 450 to like from 400 to 450. So on a global level, not so much, but yeah. Um, So from there, we went to the stock because it was per thousand population. We have the projected stock, projected population. I'm sorry. Through that, we projected the LDV stock till 2050 for different regions. You can see in both the scenarios, high economy and the low economy, there's a lot of difference. Currently, we are at around 1.3 billion LDVs world over, led by the United States, China, Europe. In 2035, the LDV stock would grow by anything between 30 to 85%. It will reach somewhere between 1.6 to 2.1 billion. That's a lot. And by 2050, it can be anywhere between 2.5 to 4 billion light duty vehicles on the planet. Um, And the steepest rise, the steepest growth would be seen in the Middle East and African countries, followed by Asia and then South America. So it's the developing countries which are going to drive this growth like enormously because the GDP is increasing, and this is going to lead to something a huge growth is what I'm saying. From there, through a vehicle retirement model, got the LDV sale from projected till 2050. So by 2035, the total light duty vehicle sale would reach some anywhere between 93 to 124 million. Like I think last year it was close to 80 million. World over, 80 million light duty vehicles were sold. And by 2050, it's gonna be like maybe 200 millions in the best case. So yeah, there's gonna be a lot more cars on the roads, especially in the global south. Now, from since I said like we didn't look at light duty EVs as a standalone category, but it emerging out from the total light duty fleet. Um, we looked at each of the country's targets, and why is this projection only till 2035? Would be a very fair question. And my answer to that is any country, I mean, has not does not have any kind of EV ambition. It's mostly till 2030 or 2035. I mean, hardly any country has any target beyond that. So we took 2035 as our, you know, uh, point where to which we projected our EV sale, and from 2035 to 2050, we assume it's gonna be a straight linear conversion to EVs, I guess. So when we talk of light duty EVs, if the countries meet their targets and commitments, okay, and ambitions for electrification, the global light duty EV sale will range anything between 60 to 73 million by 2035. Okay, so 59 under low economic scenario and 73 under a high economic scenario. So that is again, like I just said, last year we sold 17 million, right? In my very first slide. And in the next 10 years, we are going to see 60 to 70 million vehicle EVs being sold, light duty. So that's huge. Um, Further, I broke it down since we have both the high and low economic scenario. Here's a look at the major players. China is anyway a major player. It's the biggest producer. It's the biggest consumer, and looking at the stats, looking at the trends, it might also be soon be the largest exporter of EVs. So, by 2035, China would have around, this is like, if you look, if you add both all the BEV, PHEV, and ICV, that gives you the entire light duty vehicle, how much sales would be, how much the demand would be. But if you just look at the dark green part is under high economic scenario, the sale of battery electrics, okay, battery EV, pure EVs. And the lighter version of each of the bar is under the low economic scenario. So in China, the light duty EVs would be from 11 to almost 15 millions by 2035. They might be selling this much. The Southeast Asia, anything between 9 to 13 million. EU, 16 to 17 million. It's really high. Their share is really high because of their 2035 commitment of, you know, like absolutely reduced zero sale of EVs beyond that point. So USA will have kind of similar, even in the both high and low economic scenario. If you pay attention in EU and USA, the countries which are kind of saturated, there's no real growth in the demand. It's more of a replacement because, especially if you look at EU, many of the countries are kind of aging, and their population is not really the population is shrinking. it's aging and shrinking. So we did consider all that in our model. So yeah, Middle East and Africa, just see like the growth is a lot, but most of it is ISEV, which is not a good sign. South America, also a lot of growth, but this you still see kind of a balance, right? Uh, Next, as I said, like what will EV substitute? Will they like kind of just replace straight away all the ISEVs, or will they kind of just add to the new growth demand, or what's happening? So our estimation says that by kind of looking at 2035, um, EVs, the lighter bars are EV new growth cell, the darker green is the replacement cell, the darker orange is again the replacement cell, and the lighter orange is the new growth cell. So you can see in the ICEVs, the new growth is kind of really shrinking from 2023 to 2035. Okay. And most of the ISEF sales are mostly replacement. They're not actually growing a lot, if you understand what I'm trying to say. But in EVs, most of the growth is like new growth. Okay. Like replacement is I have a ISEF, it's old now, I'm buying a new ISEF and scrapping my old one. So that is the replacement sale, right? Similarly with EV. So you see, the ICEVs are basically shrinking. By 2050, we assume everything would be EV, so that's why it's all green over there. And so EVs will keep adding new growth, and the part of replacement is kind of increasing all the time. But yeah, now let me take you to these curves are very interesting, like how the replacement would be like in different regions over the years. So here we are looking at the blue lines are actually the total LDV stock, the orange line are the ISEV stock, and the green lines are the EV stock. So if you look at United States, both the high and low economic scenario look pretty much the same because, as I said, they've kind of saturated. Even if the GDP does very well, there's not going to be much changes in the LDV sales. It's pretty much similar, right? So there will be some growth in their total LDV stock, but by 2040, the ISEV will start, overtaking the EVs will start overtaking the ISEV stock in a high economy scenario. Okay, so low growth overall in the LDV stock. There is a slow decrease in ISF stock and a slow increase in EV stock, but there is a higher substitution. Okay, the substitution of ISFs by EV is pretty much higher. Okay, and with saturation in the LDV stock. So both United States and EU had pretty much the similar curves. So I did not put up the EU curves over here. Now, China, we really need to look out for. Um, can you see? Look at the blue line in the high economic scenario, especially. Look how steep it's rising. They're just woof, they're going up, right? And look at the green line. It's just following the blue line like so closely. So there is high growth in both LDV and EV stock, and in China, EVs will start to dominate the fleet anytime between by like just after 2035 to until 2040s. Definitely it's going to be um, really fast replacement in substitution in China. Now here I have the graph for India. First of all, there's a lot of difference between the high and the low economic scenario. You can see that under high economy, we are our LDB fleet will increase by almost 4 to 8 times. Like it might reach up to 300, which is not a lot if you compare it to other countries. But for us, it'll be like, but right now we're at like 34, 35 per thousand population. So that's and our population. So that's gonna be a huge number. The number of the stock is really gonna be huge. Okay, so like more than 400, almost 500 million vehicles. So but the EVs, the problem which I see here is It's mostly dominated by ICEVs. Our country will not, EVs are not kind of replacing or substituting ICEVs. They're kind of just providing some added mobility, right? And in low economic scenario, it's just ICEV growth. There is like hardly any EVs. So yeah, let's look at South America. Pretty much similar to India, but yeah, they grow both in LDV and EV stock, and by late 2040s, EV stock will start kind of dominating the whole LEV stock under high scenario. Now, this graph is for averaged out for the whole global scenario. Well, ICEVs do not stop growing until late 2040s globally. EVs will grow, but not exactly substitute the ICEV. And this should be like this has massive implication for transport energy perspective. Given energy, all electricity generated are not green as yet. We're not very green. But if you look at South America, many of the countries are kind of way ahead of the curve there. More than 90% of the energy generated is through renewables. I mean, that's mostly hydro, but that's still renewable, right? So yeah, like countries probably need to scale up on renewables because as we saw in my previous study, renewables have for the countries who are high up there in the EV adoption, they show a very high and strong correlation with you know increase in their renewable production and EV stock. So that's that. So yeah, we just discussed what will EV substitute. So like apart from I'll just summarize it. Countries which are saturated, like US and EU, will see a faster substitution of ICEDs by EV. Countries that are still growing, like Global South, developing nations, will witness a huge growth in LDV demand, but that will mostly be ICEDs. Okay, this is also because of this also adds to the fact that the supply would be very constrained because countries which are saturated, essentially the developed countries, since they are going to see a very faster substitution, more demand of EVs, there'll be less left for the developing nations to actually, tap into the EV supply. So, what I feel is the developing countries might act as the secondary or used EV cars. They might be the next market for that. But we'll see. Um, Also, since ICEVs are going to dominate the world for so long, we just don't, we shouldn't just focus on, electrification, but we also need to look at the ICEVs. We have to make vehicles more efficient. We have to make the fuel more cleaner, and, so that the climate goals are still achieved. So, but yeah, through a looking glass, the developing economies should focus, even now, should focus a lot more on electrifying as much as possible because of this new anticipated growth, and where this growth is so huge and it's not really replacing the ICEVs. Okay, now let me take you to the supply side of my work. During my work as postdoc, we developed a global model, which we call as Monet, Monet. Okay, the very famous painter Monet, and it stands for Model for International EV Trade. Okay, so I'll walk you through that model. I'll tell you what magic it does. And also, we evaluated many scenarios. Here, I'll be presenting some scenarios from the US, North America, because it's such a good case study where there's a lot of import happening, a lot of export happening. There's also EV export import happening. So, I'm going to walk you through some trade scenarios as well. So, yeah, this was the projection which we kind of just talked about. So, yeah, this is, we call it UCD Monet framework. which Monet is short for Model for International Electric Vehicle EV Trade. And here is its structure. This is also published. This was published last year, um, and by our team, research team. So let me first walk you through the input data. Monet again uses all the open source data, you know. So we used global LDV demand side prediction using EV volume sales and how much. From there, we got the global LDV production data. We use IEA data for EV sales. We use heavily use the United Nations Comtrade data, which is a huge data set on the export import of countries, and it's a huge trade data set through the code of the item which you're looking for. I mean, it's a great data set. Then we also looked at global EV sales forecasts. There are other global models like ICCT Roadmap, IEA Momo, IEA EV Policy Explorer. We also included inputs from those. Uh, and that was one of the reasons these models which I just showed, ICCT, IEA, and the Policy Explorer, they do have forecasts, but you don't know how these forecasts come about. They never disclose the data sources, the models, nothing. And that led my work on project creating this global forecast model, which uses all the global data set and it's out there in the public. Yeah. Then we use the battery tracker for battery capacity. Now, what happens in the model processing is using the LDV supply and demand data set, and using the trade data set, we created a R matrix, trade matrix. A lot of balancing required in that. Uh, since we aggregated our 190 countries into like kind of 65 countries and region, which I'll show you in the next slide, uh, the balancing is tough because there's a lot of export and re-export. So matching all the import and exports is was a huge task. And from that, we created a global trade ratio matrix, which led into the global, scenario processing and things like that. Um, so yeah, the things which we did with the Monet model was first of all creating the baseline scenario. We took data from the trade data from 2017 to 2019 because we specifically avoided 2020 and till 2022 because the trade was very much affected. The sales were affected due to the pandemic. So and 2017 to 19, the sales were the highest of their time. So we took, to avoid any kink in the data, we stick to that. And yeah, through a Monet model, through a looking glass, we projected how the light duty EV supply trade looked like in 2035. And we evaluated various trade policies that might affect this supply. So this slide kind of presents the Monet model in kind of a nutshell. The supply by any country is a function of sales and the trade ratio. Okay, this is kind of the underlying one-liner for Monet. So, but there's a lot of background data which goes in. So first, you need the demand by country, and you need the most important, the trade ratios. Okay, and that leads you to what the country would be able to, satisfy its own need and what it can supply. So, and the different scenarios which we evaluated was first, I mean, the baseline was what's happening at the current trade ratios. Okay, in 2035, what would happen 2035 trade look like if the current trade ratios continue? The second scenario was, USMCA is a pact where US, M is Mexico, and C is Canada. Like it's more of a friend shoring and near shoring, like North America forms a pact, lesser tariff for, amongst these countries, that kind of thing. So a policy of higher domestic supply and, near shoring or friend shoring. So it's kind of more of a protectionism regime, which we tested. And the third scenario was like a global free trade. Okay. So This is the trade matrix and the trade ratios which I talked about. So you see all it's a matrix, all the 65 countries. I hope you can read the country name because there's 65 of them. They're a little small, the font is, I agree with that. So the rows show you the export done by any country. Okay, like if you go from left to right, you'll see, for example, start with Germany. So it'll show you what all countries Germany exported to. Okay, if you like go vertically down. Okay, and yeah, and the columns show you the import. So and the shading, if it's more dark, that means more trade was done. Less shade, less was done. No box, no trade was done. For example, look at Iran. It only has a box with itself because of all the sanctions and the import export sanctions. So yeah, they only produce within for themselves. They don't import, they don't export, right? The trade ratio, through this we also get to see many clusters like European countries are kind of trading among themselves, the Asian country trading, the Middle East, Africa, the South Asia, trading among themselves. So this trade ratio matrix is kind of a backbone of the Monet model. Um, it took a lot of effort creating this. Um, Next, this is the projected demand of the countries in 2035. It's just a different presentation. I mean, style of presenting. Now, yeah, uh, the Sankey graphs actually. Uh, Let me help you try to understand how to read this. The one on the left is the first one, which tells us how the 2035 trade will look like at the existing trade ratio. If the same trading relation is maintained till 2035, how it will look, like I think currently um, this is all light duty EVs. Okay, currently I think I'm forgetting. I think it's just 1 million EVs or okay. So do you see the production side? United States, Mexico, and Canada. So that number tells you how much of this country, each of these country produced. All right, and then you again see the sales side. How many these country sell? United States, Canada, and Mexico. From the leftmost side, you see the imports, the vehicles, the EVs flowing into these country. Most of, like many cars from Japan, Korea, and Europe flow into United States. Also, um, the right hand side, you see the exports. Where do these three countries, United States, Mexico, and Canada, export to? Like US exports to Europe, China, Middle East, and like I hope you understand. You can read the Sankey better. I hope we did a good job. Okay, so currently the sale is around 1 million, which in the future will raise to 9.93 million in United States. And currently, I think United States produces around zero point 0.3 million, but in the future, to maintain the same trade ratio, they'll need to produce around around more than 5 million vehicles. Similarly, with Mexico and Canada, they'll have to produce a lot more because to maintain the same trade ratio. On the right hand side, what this Sankey shows is how much of battery capacity will flow. Okay, because okay, I'll give you an analogy. You know how we say when we export rice, we just don't export rice. We're kind of exporting water because a lot of water goes into growing rice, right? So similarly, when a country exports an electric vehicle, it just doesn't export an EV. It exports a lot of raw materials inside the battery of the car. So if the importing country is very good at recycling, So maybe for the initial few years, it'll keep importing. And if it's very good, if it's able to recycle, develops break technology breakthrough, and 90 or 100% of the recycling, it's just a scenario. They are like kind of, they just didn't import the EVs. They import a lot of raw materials, and they can go on forever within their country. I mean, it's just a thought, little while, but yeah. So yeah, this, just look at this graph, and I'll see. Just look at Mexico. It's producing so much, 120, almost 121 million of uh, kilowatt hour of battery capacity. But look at what it's gonna consume. It is just gonna consume less than 10 million kilowatt of, and I mean, battery capacity. So since Mexico and Canada, they export so much to US, and in US they have a tendency to own really big cars. So bigger a EV car, bigger is the battery capacity. You need a bigger battery. So a lot of raw material goes there. So it's just not what EVs you produce or consume. I think the future trade also defines like which country you export to. If you export to a country which is into really big cars, um, you'll be exporting a lot of raw materials, right? So probably you need to be wiser in what market you're exporting and things like that. So just food for thought. Yeah, these are the other two scenarios. On the left, it's more of the protectionist kind of a scenario. Okay, like how much is. So you see a very less import happening compared to the previous slide. Can you see the Japan and Korea and Europe is highly reduced because if there is of nearshoring, of friendshoring, and a regional pact in the North American trade. Okay, so a lot of lesser imports. Okay, but if you look at the global free trade scenario, we see that there is Canada and Mexico as well as United States. Um, they kind of they lose out on the production kind of goes down, and Europe and Japan gains a lot in exporting to the North America. So this is like a global free trade scenario, just a scenario, right? So yeah. So look here, just look at this graph. These are the big players, big manufacturers, big exporters, I would rather say, of light duty around the world. And we are looking at the light duty EV production under the three scenarios which I just said. The S1 being the whatever the current ongoing rate is, the same in 2035. The second being, more of a protectionist regime in North America, and the third being global free trade. Now, look at China. In any of the scenarios, it just keeps growing, right? So, even if you look at the current trade, it's anyways going to grow, even if it's protectionist. In free trade, definitely China is growing, but it's growing anyways. So, yeah. Looking at countries like Mexico and United States, um, under free trade scenario, their production is going to take a hit, right? But countries like Germany and South Korea, along with China, their production is going to increase. That means they're going to export much more under global free trade scenario. So you see how production and all supply is so much tied to the trade, which so much depends upon the geopolitics and so many other things. So it cannot be ignored, is my takeaway here. Yeah, now let me just, it's just a very kind of a raw slide. On the thing was, I just said, like, it depends on what kind of country you export to, what kind of cars are there. So here I have shown four, five segments like okay, A, B, C, D, E, F. Actually, A is the small cars, B are the sedans, small SUVs, C, D are mid-size SUVs, and EF are the large cars and the full pickup trucks. Now, this basically shows the average battery capacity required for each of the segments. Segment A is like, small cars, smaller battery, smaller capacity, EF, so much more. And the red dots actually show you the share, the global share. So clearly, segment C and D, the mid-size use SUVs, like SUVs are like, they have the highest share of sale above more than 60%. That's become like a global thing. It's no more a US phenomena now. It's even in EU, even in, I think, in developing nation, people are moving towards bigger cars. So that's not essentially a very good thing from point of view of raw materials for batteries. So yeah, just food for thought. And yeah, let's look at this slide. You know what this slide tells us? Um, this shows us for each of the country, it took like what kind of EVs are being sold and what is like the average battery capacity, including all the light duty EVs in that country. Okay, so you see, United States has, and the red line tells you the share of global BEV sale of that particular country. So, for example, we'll look at United States and then we'll look at China. So, United States loves big cars. The average battery capacity is well beyond 80 kilowatt hour. But when you look at the global BEV sales, it is kind of 11%. Okay. Look at China. It has around 60% of the global EV sale, and the average battery capacity is just 53. It's more about the smaller cars, right? So, is that why China is able to sell more cars? Because it has smaller cars. So, like, even with this kind of similar amount of raw materials, is it able to accommodate selling more cars? Probably need to look deeper into that. Okay, so this, I mean, I've basically discussed most of these points. I'll just skip it. I'll take you guys to the last section. It's more of the policy and implications for industry, demand side, research. Okay, let's dig deep into this. Starting with the demand supply mismatch and how we can, kind of strategically bind them together. So, demand is very policy driven, like countries setting targets, bringing in more renewables, right? We saw all that. While supply is very market and OEM and manufacturer and trade dependent, okay? So, the sources are not really synchronous. Um, High income regions, like for example, US and EU, European Union, they have set really high, they have really good EV targets, which is really great. But they also kind of lack the domestic raw material for processing, and kind of like in Europe, you'll see increasingly more Chinese manufacturer tying up with the local EU manufacturers, and like all the EVs are flowing in. Many of them are flowing in from Chinese manufacturers. Okay, so is it a good thing or a bad thing? Not sure right now, right? The low middle income countries like India, we do definitely face affordability challenges, and I think EV manufacturing is hasn't really reached its potential. So maybe if we put our focus there, so it might reach price parity and hence more electrification. So even trade agreement and risk industrial policy, technological partnership, everything plays a key role in, bringing the demand and supply on the same table. And we really do need to look at resilient supply chains, more localized production, making things more local, brings down the cost, gives more confidence, create new job opportunities, makes maintenance very easy, and cross-border policy harmonization for better, raw material tie-ups and things like that. I'll just show you one slide here. It's also from Monet. Um, what we did here is kind of projected, try to see in 2035 which country would be a net EV manufacturer, or in the sense it can be an exporter, and which would be a net, buyer, like an importer. So the green ones have the potential to be a net future exporter. India is in the green side. Good news for us. And the red ones are which are probably not very, like they might need to buy EVs, import EVs. So yeah, we just try to see that China is kind of sitting on the edge, so it could be it's China, right? You never know. So it's really good for countries like India, South Korea, Canada, Mexico. Mexico has got really great chances of being an increase, um, being I mean, exporter, right? So yeah, but this is under many caveats. Like we maintain the same production capacity and all, even in for EVs. So countries need to kind of switch gears, I guess, if they don't want to fall on the red side of the things, or if they don't want to electrify. It's a whole different story. Again, global cooperation and equitable trade in critical minerals comes on the table as soon as we say EV, because batteries need minerals, and critical minerals are very, very important. The graph I'm showing you here is also again one of the outputs from Monet, where the what we looked here is taking Mexico as the focal point, because Mexico supplies is one of the major exporter of light of vehicles to the US. So actually, it's currently like 30% of its LDV is supplied by Mexico to the US, but when it comes to light duty EVs, it's only 6%. So uh, in a way, as an example, as a case study, Mexico, if it wants to um, keep its trade at the same level with US, it needs to kind of electrify its manufacturing capacity really faster. That's We wanted to like see those scenarios. So what the graph here tells us, in terms of aggregate battery capacity in gigawatt hours, uh, if if Mexico maintains kind of the same trading thing, um, how much battery capacity it would need, and you know um, it would be requiring much more battery capacity if there is more nearshoring, and by how much. Okay. And if it kind of diversifies its kind of export to Latam, like the Latin American countries. Just see the purple line, okay? That signifies diversification to Latam. It can produce around 7 million units over there, because there they use smaller cars. Okay, so it running different scenarios. So what I just said, like whom you're exporting to, also kind of determines where you stand, how resilient your supply chain needs to be, and other things. So when it comes to critical materials, multilateral agreements, probably global South collaboration, countries like India, Chile, Indonesia, who can come together for not just raw materials, but also for processing and refining, strategic mineral sharing framework, and there could be some traceability system using AI and blockchain and digital certificates for responsible sourcing, because that is also a point of huge debate and contention about where your cobalt and lithium comes from, right? So some fair labor standards, sustainability certification, some ideas. Um, Also, the OEMs, when it comes to the supply side, OEMs form a very, very important role. So they'll have to pursue kind of a dual supply strategy, regional and global, looking for policy compliance in different like EU region or North American region. and global, like they can make their production global for an optimization of their entire production thing. um, you know Creating flexible manufacturing ecosystem that can allow platform sharing across different powertrains like BEV, hybrids, PHEVs. Okay, um, invest in supplier diversification, not just kind of depend on, like, you know, since the raw material and the battery packs are highly concentrated in um, 2 to 3 countries, China, South Korea, Japan. So we need some diversification in that, and battery circularity. Like recycling is gonna come in a huge way, and it's gonna play a very huge part, I believe, in the future when it comes to raw materials and sustainable battery ecosystem. Uh, Using AI for digitizing the supply chains, and you know trying climate risk assessments and how we can procure under such changing scenarios. um, Now, from a scientific perspective, as I said, I'm a huge fan of open data sources. I like working on huge data sources which are open. There should be more, like Monet was created from open source databases. So was the global demand model. So more open source EV modeling tool for more transparency, so that can be reproduced, and you know similarly integrating LCA trade emission models. You know, Now this is my final slide. I hope I'm on time. Uh, so it's kind of the major key takeaways from the different aspects of the study shared with you guys. The demand supply coherence can only lead to a sustainable future mobility, which is also green. If you're looking at electrification, so we need to synchronize demand acceleration, because demand is going to accelerate. The total LDV demand is going to explode, and if we don't electrify it now, it's gonna get incrementally difficult in electrifying it later because of the increased amount of light duty vehicle stock, which I showed you if you remember. um, so the supply need to be in coherence with that, the policy needs to be in coherence, the market need to be in coherence, the infrastructure, the EV infrastructure needs to be in coherence. So the demand policy, the supply resilience, the resource circularity, they all need to be very well aligned for true sustainability in transportation. So that was my final slide, and thank you. I'd like to thank my really wonderful research team at UC Davis, Professor Gilthal, Dr. Paco, Dr. Pablo, Dr. Lee Fulton, Professor Alyssa Kendall. And that is my LinkedIn QR code. If you can scan and like even question me even later on the studies which I showed you. It would be great to connect now. Yeah.
Yeah,
Thanks
thank
a
you so
lot,
much,
ma'am,
sir.
for such a wonderful session about the realistic developments in the field of EVs. How
Thank
exactly
you.
what is the current scenario of India and the world regarding to move towards, since we are moving towards this digital era and towards EV. So it was really good,
Thank you. Thank
and
you, sir.
because then it is really a very difficult job, ma'am, to study all these things, getting data and all. That is a
Yeah.
very difficult job, and
That is a very
really,
difficult job. Absolutely.
it's really a wonderful work you have done. So I just want to ask you one question: how did you manage to get all this data? Uh, because since you cannot rely just completely on the research papers for this particular data, but uh, so this is what my question is: how exactly
Yeah,
you manage to get all?
these all data sets are actually all open source. But like for example, the UN Comtrade data, it's there. It's been there for years, but it's very messy, you know. So we had to dig into it a lot. We had to make a lot of sense of the data. So, but that's the thing with these open global data sets. Once you can make sense of it, you can just do a lot with it, you know. So even my global demand model, um, that uses all the open data sources. I'll share the link of all these papers. These all have been published. That's why I included them in the presentation. So I would really, it will be really amazing if, you go through that. And I think in India, we should also encourage the use of more open source data. I mean, maybe probably there should be a more strong open science policy on a country level where there's free flow of data between institutions and uh, the government data sets. So I really feel that we are losing out a lot because of data not, we don't share data. I don't know, it's a trust thing, or usually at institutional level, it's not really encouraged to share data. So it's kind of a barrier. I think we need to burst that bubble, and like we could
Because
do a lot.
actually,
Yeah.
even I was also working on some project only not related to this, but it involved a lot of data collection and all, and it was really difficult to get the data that was required for such a study. It was actually
Yeah.
regarding the e-waste management and quantification in the state of
Okay.
JNT.
Okay. So
So,
that is a
yeah.
very good topic, e-waste management.
That was also it was really very difficult to get all this data from, because there were no uh, proper, like you can say, directories in which data was stored. No proper maintenance was there, so it was really very
Absolutely.
difficult for that. It was really
Yeah.
wonderful that you have done such a good work.
I think we can build global data more easily than the regional ones. At least that's what I've been facing from past few months since I'm back. So yeah, but let's keep trying our best.
So, ma'am, we do have some questions from
Yeah.
the
Yeah.
participants. So,
Yes.
first question is that what about the EV and battery flow rate of India in the current scenario?
Well, currently we are not importing EVs, like light duty EVs. I don't think we are exporting. We are not at least up there. It's just EV sales in India has kind of, I won't even say it has picked up a lot. So it's just for internal demand. Yeah, for two-wheeler segment, we are exporting to countries, to nearby countries like Nepal. But we did not consider the two-wheeler flow in Monet till now. We first started with the light-duty vehicles. So yeah, but we can, for two-wheelers, we can look into the UN Comtrade. I did one study like how much we are exporting, but we did not go towards the battery flow rate of two-wheelers. Yeah, I'll include that paper. That's a little small conference paper, so I'll include that too when I share the slides.
So, ma'am, second question is from Bhimsen Tudu, and the question is: in what ways can Monet create new business models and revenue streams for Indian EV manufacturers and service providers?
Yeah, we can definitely for business model. Monet, for a specific country, you cannot look at a country just by itself. You cannot isolate a country and look at it. Since it's a global model, I mean, that was the point of this global model, because if everybody starts looking for EVs, if everybody wants EVs, where will they come from? This was basically the whole idea of why we brainstormed, like, let's create a model, a global model, basically. So if you just want to look at India, no. I mean, in a way, but you'll have to look at India surrounded by all its the trade partners and how it's going. And for example, we did a very deep dive on with Mexico, which the Mexico government they took under consideration and they started working on it. We we could do a deep dive on India, like where all we are supplying, where all, because we do supply to African nations and Southeast nations cars, like light duty cars. We do supply it. And yes, I do remember like countries like Vietnam, Thailand, where we supply. they have kind of created their own internal ecosystem for light duty EVs. Like for example, Vietnam, we have that VinFast, which has kind of entered India now. They have started manufacturing in India, so they'll be selling to us in India. So are we doing the same? I don't think so. So it's also kind of a looking glass, like what you need to do to maintain your current trade ratio, that you don't lose out to other countries. Like I remember for the two-wheeler thing, we export a lot to Nigeria. Nigeria is, I think we export the most two-wheelers to Africa. I think Nigeria or Kenya, like, yeah. And since their policy, the country has a policy now to switch it uh, to electrify the two-wheelers, and we do not have enough electric two-wheelers to supply to them or to Nepal. Nepal has a kind of more than 90% of electrification target in two-wheeler segment. So now what is happening? Chile, like South American countries, the African countries are now importing from South American countries in the electric two-wheeler segment. So we're already kind of losing out on our current well-established trade, you know. So it's like we'll be losing that amount of trade. So I'm sure the OEMs are looking at that, and if not for demand, they for other countries who are, for example, Kenya has got very swiftly. It's moving very swiftly on electrification of its buses and two-wheelers both. So I'm sure the OEMs have an eye out on the countries which are their major importers and what policy changes are going over there, and if they are able to supply what they need. Otherwise, we're going to lose this race, that's for sure. Because Mexico, I know they have like their production lines are very swiftly they're changing to electric so that they don't lose on to exporting to US or Canada and whatever the established lines are. They're instead now looking at maintaining the current ones and also capturing new markets in the electric segments. So that should be our if you're asking me specifically from a net point of view, I'll give you a global perspective. So yeah, that would be my thing.
I hope Beamson to do your you have got the answer to your question. If you
Yeah, it
say
wasn't the exact thing, but yeah, from Monet point of view,
so, if you still have any doubt, you can turn on your mic and ask the question. So, so next question is by Satyajit Sahu. So, Satyajit Sahu, please turn on your mic and you can ask the question.
Thank you very much, sir, for giving me this opportunity. Good evening, everyone. Actually, I've already written the question. Actually, I saw a lot of data in the presentation, and I would like that this data can be used very well for prediction of future of EVs in India. So my question will be like, what can be a four key decisions that can be taken by Indian government? As I saw, there were a lot of graphs and a lot of predictions that there is a very good future of EVs in the whole world. So what could be like some game-changing decisions that can be taken by India, so that we can be one of the leading manufacturers as well as exporters in electrical vehicles?
well, that's a very good question. But see, I'll just tell you one thing. From my analysis, what I felt, like I said, currently we're at 33 light duty vehicle per thousand population. Okay. And in future, in good economic scenario, which I highly expect India doing very well, um, we might go up to 300 LEV per thousand population. That's a lot of vehicle stock. So, like what I think is forget the current existing stock. Okay, even if we are able to capture the growth, okay, that growth which is going to happen from 35 to 300, even if we are able to capture a good amount of that growth, I think we would have done a very good job. Okay, so I live in Delhi, and I see like compared to last 2 years or like 3 years, I see many more EVs on the roads right now. Okay, so one of the policy of Delhi, you might be aware, is the scrapping of the vehicles, right? And like last month or 2 months back, all of a sudden, like diesel vehicles were like banned, like vehicles older than 10 years and all. So there was a lot of mayhem, and I feel at least in my city, I know that people are feeling like if I'm gonna invest so much in a car, people here like to buy really expensive cars. So why not me? Why shouldn't I buy an EV? There won't be a 15-year, um, barrier on buying investing in an EV. It'll be fine. I'll be tension free. So I'm not saying that kind of, because that diesel policy had to be withdrawn because there was a lot of issues in the public. So I'm not saying, but yeah, this kind of is helping people look in a very good direction from the EV point of view, I'd say. Also, I think our government is doing a very good job when you look at FAME, FAME, the manufacturing for EVs, the scheme. The latest FAME, in that they have specifically targeted the bus and the two-wheeler segment. If you read the policy, even in your Delhi policy, every state has a EV policy now, which is also a very good thing, really. Um, you'll see there is a specific stress on converting two-wheelers and buses. Okay, so like in Delhi, most of the buses were already CNG. They were already kind of clean. The PM 2.5 is debatable. Okay, I agree. But what about the rest of the cities? I'm not very well versed with what the current fuel use is in other major cities, or even the 2 tier, 3 tier cities. Okay, so that thing is there, and I think India can definitely be a leader in electrification, because our what is uh, the largest carrier of India is the Indian Railways, right? It carries the largest number of people, largest amount of cargo in the world, and that is like almost 99% electrified. So we are kind of leading the electrification, and I'll tell you, I mean, India is ahead of electrification railways even from US and California. Okay, so that's like really, it's. I don't think it's just a matter of bringing the different pieces of the puzzle together and having the right mindset, which I think we have, and we have the conditions. Our OMs are very capable because of the import restrictions. Over the years, over the decades, India has a very strong OM, base, and they just need to, I guess, shift gears, and they are, I feel, shifting gears. If tell me if you've seen Mahindra's B6 and those beautiful EVs it's manufacturing. Like B6 is beautiful to look at, and I see so many of them. And I see a lot of growth, lot of choices in EV models, which is a very very positive sign. That means customer are getting choices in EV. So it's. I think we are on the right track. I mean, I'm not sure if and when we can become the leaders in the sense, if you're comparing it to, I don't know, maybe China, but we are on the right track. I'll definitely say that. But yeah, that could be one study when we could be, the top producer or at parity with China in production, consumption, and export. That could be one one thing you can look at, the market dynamics. Yeah. Any next questions?
Yes, thank you, ma'am. Thank you. Actually, I was closely listening to your words, but as of now, as I am from Odisha, and Odisha's government has also implemented this EV in all the buses of local buses that we see in the public transport, and as well as in some metros also. We are also moving into in some of the metros, so we are going into EVs. And as you stated very well, Indian Railways is 99% electrified, but still there is a mindset of the people, like as you told, the scrapping policy of 10 years vehicle. But still, the people are not convinced that if we buy a EV, then how long it is going to be with us, or what is the life of an EV with us. That is a very big challenge, which poses a big problem for people going, like as you told, from 35 to 300. That might be, that is just a prediction. But this type of mindset, like having a EV for so long, like I don't see any EV will last for 15 to 15 years as we have this diesel
No,
policy.
actually, EVs can last eternally. You just change the battery and they last eternally.
Yes, yes, yes.
Okay. And from my experience in California, like there, the man through the state mandate from California under the California ZEV mandate. You guys should read about the California ZEV mandate, which is pushed California EV adoption like up like anything. So there in the latest um, what's that called? In the latest bill, which was passed in 2023, Senate order, um, they have mandated kind of they've given like this much of 150,000 miles or 8 years. Like you need to provide a warranty on the OEMs need to provide a warranty on the battery pack, on the batteries. And I think sooner or later battery will become as a service. Like I think that's one that will be one way to go. Or even I didn't talk about that here, but I kind of personally feel like a fuel cell, like hydrogen based fuel cell, if we are able to crack down upon the cost, they are again like probably even superior to battery electrics. So, but that technology is still to be cracked upon. But I think with the right direction, or like probably we'll get there someday, someday pretty soon. So yeah.
Thank you, ma'am.
Yeah.
Last question from my side. Actually, still, like I feel in this taking of EVs or moving to EVs rather than these fuel-based vehicles, is it not still like concentrated to metro cities and all these high-end cities? Because as India is so large and as per the area concerned, the EV section is still improving in the rural areas. Not that much. It is popular in rural areas. We see that last 2 3 years, as you told, there is a significant rise in the number of vehicles, number of EVs in cities. But still, I guess in rural areas, the this number increase might take a too long period of 20 to 30 years to reach a higher number, as you stated, ma'am.
Okay,
So can you?
Satyajit, where do you live in Orissa?
I am living in Bhubaneswar.
Okay, and you just said like buses are all electrified,
Yes,
kind
yes,
of
yes,
the
yes, ma'am.
public
Yes, ma'am.
buses. So
Yes, ma'am.
do those like what about the like intercity buses? Are they also
Yes.
electrified?
No, 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 ma'am. Not yet. They're not yet into it is because of the range of the like the transport in Odisha. Actually, if you go from one place to maybe another place, is almost 400 to 500 kilometers. Like from Odisha, eastern Odisha or coastal belt to, if you want to go to the western part, it's almost 500 kilometers. So I guess this range issue is there, because of which this
Range is no more an issue. Like uh, see, you can look at range in two ways. Like for example, I'll tell you China. Okay. In China, what happens is they have smaller cars, smaller batteries. Smaller batteries means it takes less amount to charge. So they are perfect for as a city car. But when it and don't just look at light duty or cars only as the way of electrification. You know, as I said, in India the focus is on electrifying the mobility rather than I feel electrifying just the vehicles. You know, if you electrify a bus, you're providing electric mobility to more people. You know, in that sense. more PKTs being electrified.
Yes,
If you
it's about
understand what
more reach of the electric mobility.
exactly, because EVs are definitely expensive. They've not reached the cost parity with the ICEVs, and in rural India, I don't think you might have cars, but you don't straight away goes to car. You go to car. People always start with a bicycle, then they move to a two-wheeler, maybe two-wheelers, then probably a car. So just look at what segment it can be, because almost I don't know, 50%, like city like Ahmedabad, more than 50% of the vehicle fleet is two-wheelers. Okay, so let's not focus on car because we're anyways low on the car thing. Fine, but we will grow in the future. That was my point. So we need to cover that up. And right now, we are electrifying that, and many cities are coming up with metro, which are again electrified. That is also kind of electrified way of transport, right? So apart from EVs, I think, you know, dreading your grid and making it more green is also very important, and which I think we are doing that too. Like we have already gone ahead than our last Paris agreement, what we committed, right? Uh, and yes, we can do much more, but I think we're going on the right track. Like we are in a country where we cannot fast track it like China. Like it's we have a different setup and things are very organic, which is a very good thing, right? So like being on the right track is important, and um, EVs, EV specific companies like VinFast Manufacturing here, our legacy OEMs like Tata Nexon EV was like the rage 3 years back. Like it kind of opened people up to, come and try and take up EVs, and then people started, at least in Delhi, this is what I saw. Now they're trying out every other brand, like we beat MG, and I've seen BYG cars, Citroen electric. Like people are out there and they're trying different brands, and but yeah, if you're just talking about light duty, as soon, and it will reach cost parity pretty. I won't say it'll take very long. Like companies like VinFast and all starting manufacturing, which do actually manufacture cost competitive cars. And I'm not talking about Tesla selling Teslas here. Teslas are wonderful cars, but uh, probably cost is one point where Indian consumers are very sensitive and we are very picky. Uh, but yeah, as soon as we break that barrier, as soon as OEMs are able to crack that, we'll be up there. Now, next person. It's almost 9:30 now.
Yes, ma'am. We are
Okay,
taking the
there is
last
ma'am
questions only.
from
Yeah.
Yeah.
Surya Karan.
Surya
Thank
Karan, yeah, his hand
thank
is
you, ma'am.
raised
Thank
from a long time.
Hand is raised.
Ma'am, good evening to all. Ma'am, my question was that,
Yeah.
like, we are always talking about AI, AI. Is there any benchmark function to test the AI algorithm that whenever we want to develop one new one? Because for optimization function, we have a test suite 2017 and C 2022. But for AI type of algorithm, is there any such type of test suite? I want to know.
AI, I'm not very well versed with AI, Surya.
No, basically,
Like,
we're working on data and all, no? So that's all.
nee, I'm working on data. I'm more of a very traditional statistical kind of a person, but yeah, I'm very much open to learning, understanding AI. But one thing I worked on AI. I have papers on mode choice and classification using ANN, fuzzy, adaptive neurofuzzy. I worked on all that. But for those, you need a very good amount of data. If you need a very good amount of data for your model to be very well trained and make a very accurate forecast. That's very basic. Your data has to be very pre-processed. It has to be very cleaned up. Again, for the training part, so that it doesn't make a mistake while projecting. So, like your question is about any particular model, like
No, no, any model, for example, whenever ANN was developed, how it was test, because I did not find any test suite function for testing such type of algorithms. Any algorithm.
what is the problem you're solving? Like optimization? What are you
No, no.
solving?
For any, let us suppose any new algorithm, for example, let
Okay,
us
so
say,
that is a very AI expert specific
yes,
questions. I am not that. I'm not a AI expert. Let's just say that. I know the basics, but like just in the transport domain, what I worked on, choice
thank you,
models and discrete choice. That's it.
thank you.
Yeah. Thank you.
Thanks a lot,
Okay.
ma'am,
Thank you, everyone. Yeah.
for such a wonderful session and
Yeah, it was
really
great. Yeah. Okay. Okay. Jatin, I'll call you later. Okay, to
Yeah, thanks.
discuss few
And
things. Yeah.
yeah, thank you so much, ma'am. And
Yeah. You're welcome.
yeah, and for delivering such an insightful and engaging session on electric vehicle demand and supply strategy. I think the session has provided the knowledge on challenges, market dynamics, and future possibility in EV ecosystem. So I hope
Yeah.
our participants has enjoyed our this technical session.
Yeah. I hope
And
so too. Did
yeah,
you? I mean, are you guys gonna post it on the LinkedIn or something?
yeah, we will post that recorded video on YouTube,
Okay.
and we have also published this session wise that the notes on the press release in the newspaper also. So
Okay. That's cool.
yeah, so we will share it to you whenever we get
Yeah.
that
Yeah.
press release from the newspapers,
Yeah.
and I will also share that YouTube link after uploading in the YouTube, yeah, and with the participants also.
Okay.
Yeah, yeah.
Okay.
So thank you so much, ma'am,
Thank you so
and
much. Yeah.
yeah, and I am also thankful to our participants who have joined this session so patiently and actively contributing to make it
Yeah.
interactive and
More than
meaningful
100 people are
discussion.
still here. So
Yeah,
that's great.
yeah,
Okay.
yeah.
So good
So
night, everybody. Okay.
thank you
You
so much,
can,
ma'am, and good night, all
yeah.
of you. Good night. Good
Yeah.
night.
Bye.